actually exactly 5 business days, which is incredible. If you've ever worked for a large company, large companies don't move particularly fast. So the fact that I was able to mobilize a team and get folks onto the stream is just awesome. But today they're all women. And if you have tuned into this stream before, we typically do a Friday stream. You may have noticed that there's not always been a lot of women. So I hope we keep things very friendly in the chat today. I can't promise that I or our streamers can split their brain enough to follow both Twitch chat and YouTube chat, but we will do the absolute best that we can. I feel like a television producer here because I have like actual paper notes so that I remember everything. But yeah, I'm just kicking things off today. You'll see me a couple times throughout the day, but really today is about celebrating our developer advocate women and letting them talk to you about what they do. It's all pretty much going to be tech talks. It's all going to be topics that are relevant and interesting to tech right now. So we'll cover a bunch of different things. Looking at my notes here, I just want to reiterate, please be nice in the chat. If you are not nice, you will get banned. Zero tolerance today. A lot of our streamers today are first-time streamers. We want to make sure that this is a safe and comfortable space for them. We also want them to come back. So if you are in the chat and you hear something super interesting, you want more information, you want them to go more in depth on certain topics, they're probably not going to be able to do that today, but I'm sure they would be happy to come back and talk to you more about what they're working on or the tech that they're featuring, things like that. Let's see, what else did I say? We are live on both Twitch and YouTube. So if you have to drop at any point today, you have a life, need to do other things, you can either watch the video here on Twitch later or on YouTube. So awesome. If you don't know, this month is Women's History Month. Last Friday was International Women's Day. So it's not a belated celebration. I feel like we can celebrate the entire month. If you want more information about the tech that we're talking about here today, developer.ibm.com is going to be your best resource. If you want more information about how to get assistance from one of these developer advocates or others on our teams, there's a couple different places that I like to send folks. Down at the bottom footer of developer.ibm.com is a link called Answers. It's kind of our Q&A forum. I would recommend that. I would also recommend Stack Overflow. We have a number of different folks looking at the different tags there for our IBM Cloud technology. We also have a Watson Developer Slack. I can post that link later because I don't think our mod necessarily knows where that is. It can be a little bit hard to find, but we have folks there that are happy to answer questions as well. We also have city and geo teams, which are super cool. So we host local meetups, we go to local events. We want to make sure that we're giving the developers in certain geos the content that they want and need, because we understand that there's some industries that are in certain geos and not others. There's certain problems being solved in some geos and not others. So definitely check out developer.ibm.com for more information on the different cities and geos that we have represented to find a meetup or an event near you. I think as far as everything I wanted to cover for kickoff is done. The only thing that I wanted to reiterate was this was a completely kind of grassroots event. So most of the streamers today are going to be on the stream for the very first time. They may be a little bit slow at answering questions in the chat, so please bear with us, keep this very friendly. Also, we pulled this off in a week, in exactly 5 business days. So that's super cool, and I'm still in awe of it. When I wrap up the stream at the end of the day, I will go through and thank each and every individual that's helped us to get here. And yeah, so with that, I am going to jump off and get our next presenter up and running. It's going to be a full talk on quantum, and I'm super excited for it. Take care. Awesome. Awesome. No, it's Jody and Maddie. I will ping both of them. And can we ban Willem 12? No, ban him.
computing started in the 20th century, and the idea was that our classical computers are very good at solving just very discrete problems. However, if we really wanted to approximate or really get a very clear picture of nature, things that happen in nature, very complex problems, um, we really needed to get into using quantum mechanic principles in our computing. And that's the idea of getting behind our quantum computing. This is a quote from Richard Feynman. I'm not happy with all the analyses that go with just the classical theory because nature isn't classical. Damn it. And if you want to make a simulation of nature, you better make it quantum mechanical. And that's very, very true. If you think about it, the world operates with quantum mechanical and classical um, principles. Life is chemistry. This is actually a quote from Watson of Watson, Crick, and Franklin thing. And chemistry itself, for as an example, I'm a computational biochemist by training. Using that example, your quantum mechanics is actually part of the reason life works the way it does. So, again, that brings us back to why quantum computers. We want to really get at that. So, let's talk about what is quantum computing. Okay. A quantum computer is simply a computer that uses quantum mechanical phenomena to manipulate that information. And the way that we go about doing that is instead of using classical bits, like our zeros and ones, we use quantum bits, which we call qubits. And this is a picture of our chandelier design. It's a beautiful, it's a beautiful computer. It's a piece of art in addition to being a computer. And this is a quantum computer. This is an IBM quantum computer. So why is everyone so excited about all of this, right? Because these things are really, really efficient. They're able to represent multiple states at the same time. So why is that important? The computing power of a quantum computer doubles with each qubit that you add. And each qubit can model or can represent an individual state of whatever feature that we're talking about. So if you have 275 qubits, you can actually accurately model uh, a larger number of states than there are atoms in the universe. That's really, really powerful. And that's going to end up leading to very amazing breakthroughs in multiple areas: chemistry, drug discovery, artificial intelligence, optimization. Um, there's a ton of different things that are quantum applicable problems. So let's talk about the differences between classical bits and qubits. As we were talking about these different states, you can model two states, so zeros and ones. With classical systems, that's what we know. It's either 0 or 1, right? With quantum bits, yes, you still have 0 and 1. However, when we're talking about classical bits, you can only have 0 or 1. There's no in between. There's no probability that it's 0. There's no probability that it's 1. It's either 0 or 1. Or sorry, when I say there's no probability, I mean it's the probability would be less than 100%. With quantum bits, you do not know what state you're in, potentially. It could be 0, it could be 1, it could be a superposition, which we're going to talk about a little bit more about in detail in a second, but you don't know what that state is until you measure it. With classical bits, you don't have the quantum mechanical aspects or features, if you want to call them that, of superposition and entanglement. And again, we're going to define that in just a minute. Quantum bits, both of those are possible. And to double the power of a classical machine, you have to double the number of transistors. With quantum bits, all you have to do, again, just add 1 qubit. So let's talk a little bit, just to give a more concrete example. Your classical bits are like light switches. They're on or they're off. On or off. There's no in between. There's no, I don't know if it's on or it's off. You know for a fact if that light switch is turned on or off, right? If you look in the picture here, you can see my little Tesla ball, right? When we're talking about qubits, I want you to think more in 3 dimensions. So in this case, we have our qubit. We don't know which state it's in. It could be over here, over here, over here. It could be anywhere, right? We don't know until we measure it, just like this, right? Okay, so that is just a visual example, a visual analogy. When we're talking superposition and entanglement, what I want to do is to try to demystify this. Superposition is, we say it's a combination of 0 and 1. It's 0 and 1 at the same time. It's kind of a joke, right? You've probably heard a lot of quantum jokes if you're interested in this. What this means is that it's really more probabilistic. So a little bit more complicated definition here. You have a chance that it's in 0. You have a chance that it's in 1. We don't know, again, until we measure it. And that is really the concept of superposition, that it's probabilistic as far as which state you're in. With entanglement, this is the spookier aspect. This is where your qubits are acting in concert together and you can't differentiate them or describe them independently of each other. So if one turns one way, the other one's going to do the same thing effectively. They're behaving as they're linked. So that is entanglement. And we're going to take advantage of these two features or these two phenomenon when we're talking about quantum computing. So let's get to the fun part. Who wants to play with a quantum computer? Can you do it from your phone? Yes, you can. You can use phone, tablet. Let's go ahead and let's jump in and start doing this. I'm going to give you the link to the quantum experience. And this is our general public access to our quantum processor. And you can do this via the cloud. So there is the link. The link is also in the chat. And you can, at this site, you can run simulations or actual experiments. There's a lot of really good information. There's a beginner tutorial. There's a full tutorial guide. And then the first thing you're going to see when you log on is actually the forum. So this is our community aspect. You can feel free to ask questions, start a discussion. What we're wanting to do, you can learn, here's where you have access to the different devices and information about Qiskit, which again, Maddie's going to talk about in just a minute. That's our SDK. You can also have access to all the learning resources. You can watch some videos. And again, here's the community. Here we go. There's blogs. There's also a Qiskit Slack channel that you're welcome to talk to people about or talk to people in. And what we're looking for here is if you go up to the Learn menu, the Composer. So IBM Q Experience Composer. Give you just a second, follow along. Okay, so this is what the Composer is. So we're going to talk just a little bit about this. And again, there are 3 different ways of interacting with the Q Experience. You can use the Composer, you can use Qiskit, which is our SDK, or you'll see it mentioned on the you'll see it mentioned on the Composer site that there's a quantum assembly language, so QASM or OpenQASM. We're not going to talk about OpenQASM today, just for time. Okay, so when we're using the Composer, and we're going to actively do this as part of a demo together in just a minute, we're using gates. So you're going to hear some terms about gates when we're talking about program, both in the Q Experience Composer and in Qiskit. So some of the ones that you're going to see are measurement. You're going to hear some poly gates, X, Y, and Z, and a Hadamard gate. And what these do is they accept inputs and they produce outputs, and they'll hand it to the next gate, and et cetera, and so forth. But they also operate simultaneously. Now, if you're confused at what these gates are actually doing, and we're going to go through some of these in a little bit more detail, there is a really great game that's available on the iPhone and also on Android. So you can get those from the respective app stores. It's called Hello Quantum. And it's pretty simple, but it shows you what the gates are doing, turning qubits on and off and signals and swapping positions. It's a really great way of getting a visual and to wrap your head around the concept. So I highly recommend that. So let's talk about the composer and the layout here. This is how you're going to create your quantum circuit. When you're going to program your algorithms, you can also call it running an experiment. A lot of times that's what we call them, is you're actually running a physics experiment. So the composer is sometimes called a score, and that's because it looks like a musical score. If you've ever read music or played music, the score with the lines that show where the notes are, that's kind of what this looks like. And we're going to operate that the same way. You're going to grab your gates from over here. So, and here's the X, Y, Z, the Hadamard, and the measurement gates that I was talking about. Those are the ones that I'm going to talk about in this demonstration. Now, you can program more complicated algorithms using the Q experience. And this is, for example, this is an example of Grover search algorithm. And this is commonly used as an example. Again, these are ways of searching databases or constructing things for optimization, but it's just a type of algorithm. So one thing I do want to point out is you can either run the experiment on the actual quantum computer. Because of time, what we're going to end up doing is running it on the simulator. That way we make sure we get our answer, barring any sort of internet connection issues, right? Okay, so the first thing we want to talk about is the measurement gate. This is very important. Your program will not run without one. All this does is it's going to measure our qubits. So you're going to place this on the qubit that you want to measure. Your qubits are arranged from 0 to 4. So the first qubit has the 0 indicator. Second one is qubit 1, etc., and so forth. We're going to use a 5-qubit system that's publicly available on the Q experience. And when you measure your qubit, you're going to get a measurement. It's going to calculate your score and then give you a bar chart. And it's going to give you your probability between 0 and 1. It's also going to tell you the state that that probability corresponds with. In this case, for example, we have not made any sort of changes to our initial qubit. It's still going to be in our 0 state. So of course we have a 100% chance of it being in the 0 state. So let's see that in action, right? Okay, so I'm going to come down here and grab my measurement gate. I'm just going to put it on the first qubit. Okay, just drag and drop. If you decide you don't want that, what you can do is double click and then it goes away. Okay, very simple operations here. So let's go ahead and put that in. And we're going to hit simulate. It gives us a number for our experiment. You can rename your experiment. It'll keep track. We're going to get our quantum score. It's created the code to run this. This is our graphical user interface for doing all this so you can learn. And here is the results. So you can see we have all 5 of our qubits are in their original state, their 0 state, and there's a 100% chance of that happening. Okay, so that's all that is. All right, the next thing we're going to talk about is we're going to talk about one of the Pauli gates, and that's going to be the X gate. This is similar to our classical NOT gate. We also call this an X rotation because you're basically rotating the pulse, if you will. It creates a bit flip. So what we're going to do, and this is the important part, we're changing our 0 state to the 1 state. With the Z gate, we also can do a phase flip. With your Y gate, you can do a combination of the two. We're just going to keep things simple for this demonstration with putting an X gate on our qubit and measuring that qubit. Okay, so let's do that right now. Okay, so I'm going to move my measurement gate over and drop an X in. Now, because we are rotating and we're flipping our bit from 0 to 1, what we're going to see is that qubit, and it's just the one, or the Q0 qubit. Okay, so we're only flipping one qubit. As you can see here, we're not flipping all the rest of these qubits. We have flipped it, and we haven't done any sort of superposition. We haven't done any sort of entanglement. We're talking about one simple qubit and flipping it from 0 to 1. We have a 100% chance of that first qubit right here being in the 1 state. Okay. Okay. So the next gate is a little bit more interesting. This is our Hadamard gate, and we use these to create superpositions. So the way it's doing that is it's actually rotating in 2 directions. It's rotating pi radians around the x and the z axes. Okay, and this is going to exchange our x and our z. And that's how we end up getting that superposition. Now, remember when I was talking about superposition being probabilistic? That's exactly what we're going to end up seeing. You have, for this demo, and the probabilities are going to change given your experiment runs, okay? In this case, your first qubit may start over with the Hadamard.
Yeah, that's a very important gate for them to understand, so I would.
Yeah. Okay, cool. So I'm not sure where we got cut off, so I'm gonna start over with that Hadamard gate. We're back. And so the Hadamard gate is a little bit more complicated. What we're gonna do is, we're gonna create superposition here. And the way we're doing this is we're rotating it in 2 directions. We're rotating the qubit in 2 directions. We're gonna rotate pi radians around the x and the z axis. And this is going to exchange our x and our z, okay? So what you're going to see, and again, we're only working on 1 qubit. So we're just going to change the state of 1. But when we're doing that, remember when I said superposition is probabilistic in nature? This is where we start getting some probabilities. So you have the 1 state for that qubit and you have the 0 state for that qubit, right? Well, instead of having, oh yeah, it's definitely going to be in state 1 or it's definitely going to be in state 0, because we've created this superposition, you have a probability of 42% being in the first, or in state 1, and you have 58% chance of it being in state 0. So let's see this in action and see what happens. Okay, so I'm only going to be putting the Hadamard on here. So we're going to start with our first qubit, Q0, in the 0 state. We're going to hit it with Hadamard and measure. So let's simulate and see what our probabilities are. Okay, so we got 52 and 48, but it's the reverse. If you can see the slide in the background, it's the reverse, right? Okay, so when you're running these experiments, and again, this is just on 1 qubit, just to show you, it's going to be somewhere in the range of, I mean, if you do it enough times, 50-50. But when you're running the small batches, because of that probability nature, you're going to see different probabilities. Okay, now, so this is 52% chance of it being the 1, 48% chance of it being in the 0 state. Okay, let's add one more gate and see what happens. Let's compare. Again, because we are dealing with a Hadamard gate, we're going to end up with 2 different possible answers. Okay, so again, we're going to move this over. I'm going to use my X gate. So we're flipping this from 0 to 1, and then we're going to hit it with the Hadamard. Let's see what happens. Okay, we're still ending up with two different probabilities, right? Okay, so 45% chance of it being in state 1, 55% chance in this case of being in state 0. Okay, so let's talk about entanglement. This is where we're talking about creating Bell states. And there's this Bell states could actually be an entire lecture on their own, dealing with Bell's inequality. We're just going to focus on how to implement this using the Q composer for time. So when we are doing this, we have a 2-bit entangling C0 operation. So to entangle, I mean, you can't just entangle 1 qubit, right? That doesn't make much sense. It's 1 qubit. You need 2 or more in order to entangle. So how do we go about doing this? Again, we've got the 2 qubits on the left. So in this case, we're going to use that Q0 and Q1 qubit. And I'm going to put it in superposition first with the Hadamard, and then I'm going to entangle these qubits. And then we're going to measure both qubits in this case. So we need 2 measurement gates. And then we're going to check out the probabilities. Now, when we are reading these, you see down here that this second qubit is potentially going to have a 1 in it, right? Okay, it could be 1, it could be 0. Because we're measuring the 2 qubits, out of those 5 zeros and 1s, you're going to have 2 of those changing. So let's see this in action again. Okay, so I'm going to put this one here. This one here. I'm going to get rid of my X, move my Hadamard over. And then what I'm going to do is I'm going to drop my plus onto the first qubit. Notice how the next 2 lines are highlighted. Those are the 2 places, those are the 2 qubits that I can connect. So I can connect with Q1 or with Q2. I want to measure, in this case, just Q0 and Q1. So I'm going to just connect these 2. The connections, and this is another discussion, have to do with the directionality of the connections between the qubits in the system. Okay, this is our bow tie configuration of our qubits right here. So we're going to run this and see what we get. And we are creating a very small Bell state. Okay, here we go. Okay, it's in the queue. We'll come back to that in just a little bit and try it again. This is why I had pictures made. So you'll see down here when this finishes computing that your states are going to be different. Now, this is also, if you throw in an X gate, then this is going to actually end up changing. So here is where we throw in the X gate. And again, you going, when I did this, the possible states were 1 and 0 and 1 and 1. And they actually ended up staying that way when I was running the experiments. Now, I'm just curious to see if this is done yet. That brings me to one point I should probably mention is when you're running a whole bunch of different experiments, you don't have to necessarily keep one page open and then do another experiment in the next page to compare. You actually have your experiments recorded down here. So if you wanted to run this again, you're able to do it. If you're wanting to tweak your results, you can do that. You can show them, or you can just flat out remove it if you want to. But when you're learning, you can use this kind of as a notebook to keep track of what you were doing, what kind of operations, and then how the results turned out. Okay, now, if you are interested in doing this, these operations actually are described in the IBM Q Experience Beginner's Guide, and I dropped the link in the chat. Feel free to start there at the very beginning. It'll walk you through each step. It goes into further detail about superposition, entanglement, Bell states, search algorithms. There's a wealth of information there. And when you're done with that, you can progress over to using the SDK if you're interested in doing that. And that is Qiskit, and Maddie is going to talk about that. Further reading on quantum computing in general, before I hand you over, the definitive guide is Nielsen and Chong's Quantum Computation and Quantum Information. And that is this book right here. So I highly recommend that. It's a wealth of information. It's great. Another one is a recent book by Dr. Corbett Moran, and she has written this. It just came out, so I don't have a copy of it. It's Mastering Quantum Computing with IBM QX. And then there's another one that came out last year that is also detailing, it's by Silva, Practical Quantum Computing for Developers, and it details how to use the Q Composer and a little bit about the assembly language that we didn't talk about, plus Qiskit. So that's a lot of information to get you started. We are going to have content available on developer.ibm.com. The main place for quantum computing information, content, tutorials at IBM with IBM Q is the Q Experience. Okay, definitely check it out. And I'm available on Twitter if you want to reach out or ask questions. And thank you very much. I appreciate it. Maddie, over to you.
Okay. Hi, everyone. I'm Maddie. I'm a Qiskit developer. I have been a Qiskit developer for about the last 3 months. And prior to that, I developed demos using Qiskit to help show off how cool it is and how cool quantum is generally. So I'm just going to give you a brief walkthrough of Qiskit, just the basic things. So this is the website. And as it says, Qiskit is an open source quantum computing framework, and it's all written in Python at the minute. There's loads of helpful links on this site. So, getting started videos, try Qiskit options, and loads of community links as well. And I'd really recommend checking those out. Okay, so getting started with Qiskit. There are 4 different levels of Qiskit: Terra, Aqua, Air, and Ingis. Terra lets you program gatewise. So this is just like what we've been doing in the IBM Q Experience with Jody. Aqua provides high-level implementations of many algorithms that can be run on today's hardware. Air provides all the different simulators and Ingis helps with looking at noise in the devices, because noise is a really big problem in quantum computers at the minute. So it's really important to be able to look at that. Anyway, let's get started. So the first thing we have to do is just run our imports. And so this just imports all the basic bits from Qiskit. And then next thing we have to do is to declare our registers. So we're declaring these registers of size 1. The quantum register is the qubits we're going to be using. So in the Quantum Composer, we have 5 qubits available to us, whereas in Qiskit, we are able to be flexible. You're allowed to have up to 24 qubits, but your machine might struggle to simulate that many, so I wouldn't recommend making circuits that big. But yeah, we can have registers of 1 qubit here. So if this were to be visualized in the composer, it would just be a stave with a single line. The classical register is where we read our values from our qubits into so that we can then access them. And then, no, not really. Yeah. I'm just, oh wait, yeah, no, I should be looking at the Jupyter notebook. Oh, okay. Well, the Jupyter notebook would probably help. Can I change that, or do you have to change that? New share. This one. Can you see it now? Oh, okay. Well, I'll point out the website again. Here's the website with yeah, all the getting started links if you just have a look through this. So yeah, we run our imports. This is the bit I was pointing out, these register bits. And then, yeah, okay, so we create the quantum circuit by adding these 2 registers to the circuit. The reason you do it like this is because you can have potentially multiple registers in one circuit. And you might want this if you're creating a circuit with lots of different qubits, all with different purposes, and you want to give them more specific names. And now we have to add some gates to it. So this is the same as dragging and dropping in the Q composer. We have our circuit QC. We then add an H gate to it onto the qubit in the 0th position in our register. So there are loads of different gates in Qiskit, all the same ones that are in the Q composer, and they all use the same syntax: circuit.gate, and then as parameters, the qubits you want to apply it to. So it's really easy to get the hang of. We then have to put in our measurement, and then we measure. So what we're doing here is we're measuring all the qubits into all of the classical bits. And so run that. Oh, didn't run this one first. There we go. Okay, and now what we have to do is get our backend. So this is what's actually going to run our program. As I said before, Air provides simulators, but we're just going to use Basic Air. Basic Air is the simulators included inside Terra. So we could use Air, but we'd just use Basic Air if we don't have Air downloaded. I would recommend downloading Air though, because there are so many different types of simulators included. So we get simulators that return counts, very similar to in the Q experience, but there are also some other really cool simulators which do things like return the state vector instead. And also on the simulators in Air, you can tune the noise, and I think it's pretty cool. You can use noise models that they automatically generate based on the parameters they receive from the real devices. So you can run on a simulator with the noise as if it was a real device. So, oh, no, view, I'm not sure where the zoom is. There you go, is that better? Okay, sure. Okay, so then we get the job, and then so what we do is we create a job by executing this circuit on the back end we've chosen. We then are going to print out our results, and we can see we've got about half the time 0, half the time 1, and that's because we applied the Hadamard gate, and so these are the exact same results that you would have got from the Q composer. So now we're going to look at a Bell state. It's a slightly different Bell state to the one Jodie was showing, but there are a few Bell states, like she said, lecture in itself. So because we're doing entanglement, we now want to have 2 qubits in our register, which means we need 2 classical bits to read their values to. We then create a circuit again, and now we have to add our gates. This is an example of a multi-qubit gate. So this is the controlled NOT gate, which is what we use to introduce entanglement. The first qubit in there is the control, and the second qubit is the target. And then we do exactly what we did before, and we get our backend, we run the job, and then we get our results. So we can see we've got about half the time 1, 1, and half the time 0, 0. This is because the 2 qubits were entangled with each other, so they had to do exactly the same thing when they were measured. If we were running this on a real device, or perhaps a simulator with a noise model, we'd probably get some 1, 0 and 0, 1 terms in there as well. So there might be like 100 of them or something. And this is because of the qubits decohering when we don't want them to. So this is them changing state when we haven't asked them to. And that's, again, a big problem in quantum computers that we're trying to solve. There are also loads of really good plotting functions in Qiskit. So we can generate a plot just like the one from the Q experience. And these are all tailorable. You can change all the colors and things like that. We can also do some quite cool stuff where if we wanted to run the same circuit on 2 different devices, we can then plot the results against each other. So these are just 2 simulator runs, but we could imagine that they were run on 2 different devices, and we can see how the noise and how the results differ depending on the device you run on. So that's a very brief intro to Terra. I'm now going to talk about Aqua, which is the more high-level algorithms, but for near-term quantum computers. There are loads of different algorithms in Aqua, from finance to chemistry to optimization. But the one we're going to talk about today is machine learning. You might be thinking, why do we need machine learning? We're doing fine with our classical hardware. But in actual fact, when the problem spaces get really big, when there are lots and lots of features, classical computers really struggle. And quantum computers, although the hardware isn't there yet, are expected to be much better in this problem space. So these are the kind of problems that, these are the kind of algorithms Aqua has in it, problems that are expected to be better on quantum computers, but not necessarily are yet, but because the hardware isn't there. So again, we run our imports. It's just a load of imports. Like if you wanted to run this for yourself, you could literally just copy and paste them because it's all pretty similar. The machine learning algorithm we're going to be using is a support vector machine. So this is a classical machine learning technique, but we use the quantum computer to help us find these support vectors, which then do the classification. The problem has to be a classification problem, and all of the features have to be numerical with then a classification on the end. So the data set we're going to look at is the breast cancer data set. So there's lots of different features, different parameters about the tumor, and then a classification on the end about whether it was malignant or benign. So the first thing we do is load our data set. This is just literally loading it in from a file. And then we split it into data points and what the labels were. And then we plot it. There you go. And so support vector machines work by trying to find a vector through the problem space that classifies the data into the 2 halves. So we can probably by eye see there must be some vectors that do that. So the next thing we do is create a feature map. We can only use 2 or 3 qubits at the moment. That's just a limitation that's imposed. And then we use this feature map and all the data we loaded in to create a quantum support vector machine kernel. In that way. And then we do, so this will take, I'll set it off now, but this takes quite a while to run because it is a much more complicated circuit than the basic circuits we were running earlier. We do things very similar to how we did them in Terra. We get a backend, and then this bit's slightly different. You create a quantum instance which has all the information about your execution on it, and then you give that to the support vector machine. It then tries to get these support vectors, and then will print out these results for us. So it'll print out the ground truth, the prediction, so that's what our quantum support vector machine thinks the label should be, and then the testing success ratio, so how often the ground truth and the prediction lined up. I'll leave that running for a minute because it takes quite a while, but all these things have, you can tailor the number of shots you give them. So the shot is how many times the quantum computer will run your circuit. So previously when we were up here, it was running it, 1024 times. Yeah, you can say that add up to 1024. Whereas down here, I'm only going to run it 10 times because the circuit is so complicated and it would take forever otherwise. But you can also run it on one of the simulators in the cloud if we were using Air or IBM Q. But this one's just a local simulator. There's also loads of other information in the results object, such as the kernel matrix. So we can see, here's one I did earlier, the kernel matrix from a previous one. I'm just leave that running. So there's loads of great tutorials for Qiskit. Let's see if I can zoom this one as well. Okay. So this is the repo, Qiskit/Qiskit tutorials, and this has all the great tutorials to get you started with Qiskit. If you click on Qiskit, you can see there's tutorials for all of the major elements I told you about, and also basics. So that's where to get started. I would also really recommend having a look at the community tutorials. So a lot of these, well, these were all made by people in the community, and they can be a little bit more fun. You know, they're about real applications sometimes. And yeah, you know, there's games and stuff in there as well. So it's a really fun place to get started. Also, Qiskit is an open source project, so you can go and look at the repo, and we have got a fair few issues at the moment. And I would really recommend anyone who's a developer who has a bit of time and would like to contribute to Qiskit should go and have a look at some of our good first issues. Because I think a lot of people think, oh, I don't know anything about quantum, I couldn't possibly help with this. Or in actual fact, a lot of these issues are very much computer science issues. So if you see this top issue, we need a consistent visualization. That's just drawing things. That's just a computer science problem. You don't need to know about quantum. Of course it helps, but yeah, so any of the repos you would like to contribute to, it would be really great. There's a Slack channel, a Slack workspace as well. I think that's in the chat. If you want to ask me any questions on there about getting started, I'm more than happy to help. But yeah, other than that, does anyone have any questions? Do we have any questions? Okay. Yeah, unless Jody, do you have anything else you want to add about Qiskit or anything?
No, so far so good. I think we've covered everything just to get people started. This is a great taste of everything. Feel free to reach out to us, to jump in there, get your hands on this, just play with it. Have some fun with the Q experience in Qiskit. That's all I have.
Yep. And it's got a really great community. Like if you want to start any pull requests or message anyone in Slack, everyone's very friendly. They'll help get you started. We all started somewhere, so.
Yep.
Yeah.
We have a lot of fun. So.
Yeah, that's true.
Come with us. We have fun.
Okay.
Thank you.
Well, thank you. Bye.
Bye, everyone.
Hey everybody, my name is Megan Kostick and I'm a developer with IBM, and today I'm going to be talking about Shiny Dashboard. So I started working with R in Shiny probably only a few months ago, but I've been learning something new every day and really enjoying it, and I think it's a very powerful tool. And I'm traditionally a backend developer, and this has allowed me to take the stuff that I'm doing in the back end and display it on the front end and not be so challenging as what all those front end developers have to go through. I admire them so much. So I created a GitHub repo, so all of the code we look at today will be out there for you to go check out at a later time. And I included, so some of the tutorials I walked through when I was getting started is there's a really good one just out on DataCamp for learning the basics of R. And then Shiny and Shiny Dashboard really have some great documentation and tutorials to go through as well. And essentially, if there's something you're trying to do, someone else has probably tried it, so you just Google and find out the solution. And in order to follow along and run this, if you don't already, you'll need to have R installed on your machine as well as the IDE RStudio. And then Shiny Server would be if you were actually going to run this code remotely or on a different server. So let's get started just taking a look at, so RStudio is the IDE that you can do all of your Shiny development in. It's a really great tool. Essentially, it has, let me move my little window out of the way. You can see all your files here. They have some really great built-in, essentially go pick out the packages you want to have installed, and it installs them for you. And the help is really good. I like this a lot, just having the documentation at your fingertips to look up, well, what does this method do or function? And they give examples and everything like that. So it's awesome. Probably for any IDE, I've used this as one of my favorites. And then we'll get to what the viewer and plots views do as well. So what I thought we would start with essentially is go through just Shiny itself. So Shiny and Shiny Dashboard, they're a little bit different, kind of the same, and just get the basics of kind of how the IDE works and what you can do with Shiny itself in R, and then we'll move into the more advanced. So my role with my team now, I do a lot of dashboarding, and I use Shiny to do that. So the Shiny dashboards, and you'll see why I love it so much later on. So the basics of a Shiny app, I don't know when the switch happened because I'm newer, but you used to have a separate UI file and a separate server file, which is still supported, but they now allow for you just to have this single app file, which is kind of nice. So the basics of a Shiny app are you're going to have your UI function, and a basic Shiny page, there's a lot of different choices. I'm just going to kind of go over ones that I use myself on the daily. Would be just a fluid page. We're just going to put in a simple HTML title. What's nice is there's a lot of built-in HTML tags, but Shiny, well, R itself and Shiny allow for you to essentially customize all this CSS, and you can inject JavaScript and all sorts of things. But a lot of it, they've just created these convenient wrappers for you. And then our counterpart is the server function. So this will be where you do essentially all of the heavy lifting, handle what goes on within the UI itself. And so here we need to have our, all right, and then once we have those, all we need to do is call Shiny app, and it has really great IntelliSense. I enjoy that as well. And you'll find with R, so we can essentially, anything that's required for the method, you can either include the label for it, or we could also just do something like this when we pass it, not Shiny, that should be server. Or we can also do that as well. So it's probably starting out, I like to include certain things, or if I'm not sure if I remember, like, was that the label? Is that the ID? To include those. But once you get going like this, you don't need to include it necessarily. And so we'll save that. And so in order to run our Shiny app, and I've included the library up here as well, we simply click this Run App. And they have a viewer, which you can also have the option to open in the browser. You can also, I believe, just view it over here in the viewer. But I usually choose the option to have it show up in this separate window. So let me close out of that. So that was literally all it takes to build a Shiny app, which is pretty awesome. But we're gonna do, let me copy over our next step. So the great thing about Shiny apps is, I think, the reactivity feature and how it takes care of that all for you. So I'm not going to type out every single thing just for time's sake. I'm going to copy just over the data set I'm going to use. So let me uncomment this. So if you go through the R tutorial, it's going to explain everything about the different data structures that are common to R. So there are matrices and vectors and data frames. I mostly deal with data frames because I'm querying from SQL databases, which you'll see on a future step. But here I just, created one by hand for simplicity. Actually, let me move this over so you can see everything. And it's just a little cat or a little pet database that we're going to be using. So we're going to make our UI a little more sophisticated this time. So, and in order to see, there are tons of options for, how you can style the UI and the different things you can add. But essentially, I'm going to have a header panel, sidebar panel with a selectable input. And there's different types of inputs. So with the select input, essentially a drop down, you can pick what you want from there. With this one, we'll give it a title that we can use in other areas. It's kind of like an ID for us to call and know where that is. And then the label is the pretty thing that's going to be essentially our header. And then we are going to have some choices. So this will be the unique set of choices that will be featured in our dropdown. And I'm going to grab it from our pet data frame. And we want to choose the unique set of names. So this will give us, essentially, it's going to give us this list of names. But that way, if we make a change, you can also just write them out as strings, but that way, if we make any future updates, we won't have to deal with that. And then you have the option to choose which one is going to be selected. So for now, I'll choose this. A lot of times people go, you can also pick like whatever the first one is in the list as well. So this is going to be our new UI. So we'll have a header panel with a side panel with a selectable input. So what the other piece we need for our UI is going to be our main panel. So this is where I guess all the magic will happen. And I'm actually, well, I'll type one of these and I'll copy it out. So just like before when we had an H2 tag, we're going to have an H4. We'll make it a little bit smaller this time. But essentially, the basis of this app is you'll pick a name of a pet and it's going to show you its information. Very basic, but you'll see how the reactivity in Shiny works. So in the main panel, what you'll want to choose is a type of output, essentially. So up here in our sidebar panel, these are going to be our inputs, so things that the user is inputting. And then in our main panel, we're going to have outputs. So these can be different, graphical displays, text displays, photos, anything that you want it to be. But for this app, we're going to do some text output. And essentially, this is the ID. So the way for us to access this text output object. And I'm going to copy the other few for time's sake. and uncomment these. The only thing, and it's probably something I need to look up in the ID, is there is a shortcut. Okay, it's just different than I'm used to, so I need to get that memorized. Okay. So here then we'll have essentially 4 different text outputs that we're going to update down in our server function just to display the information about the selected pet. So what you do down here, so we're passing in the input and output objects to our server, and that allows us to control between the UI and the server itself. And in order to access those, so we're going to start with pet name. This is how you'd access the output, and that links up here to this text output pet name. And then this is going to be a reactive value. So there's various reactive functions specific to these output objects a lot of time, as well as just the plain old calling reactive. But here, since it's text, there is a nice method called render text. And we essentially know the pet name, it's our choice up here. So that is simply going to be an input value name. So anytime that the name is changed or selected, it will update this pet name. So let's move on to the next one for this. So for pet type, this one is where it gets a little bit different. So we're still going to be rendering text. Is we need to, and this is, I feel like I usually deal with the SQL data frame so I can access it differently. But here we're essentially trying to filter on this data that we've entered. So we want to make sure, given whatever the name is, that we choose the right type from our data frame. So what we're going to do here, and I need it to be a string when it's returned. So I'm going to use paste. Paste is essentially almost like the toString method of R. And we're going to grab from our data frame. And in order to access the specific element, we can choose pet data. So essentially, we're kind of filtering, saying where the name equals the given name. And in order to explain this better, I need to do some more research, but essentially you need to have that for it to know to filter only that specific value. And then we're going to grab the type. So this will, given the name input, it's going to grab the type for that given name. So we're going to do the same for the, actually I can just copy from here, for the age and for the color. So I'll just do this really quick. And then we will see it all come together. Okay, so we have everything updated for our outputs. So if we click play now, oh, what did I do? Function pet data. That's interesting. Okay. All right. We are debugging this, I guess. Maybe I messed up at the top. Oh, right here. I believe. We don't need to call it multiple times. Okay, let's try that. There we go. And because of my screen size right now, okay, there we go. Okay, so this is the header panel up here. And then we have the sidebar panel that we created with the select dropdown, which has our unique set of choices. And then essentially, since Missy's selected first, it just prints out, these values that are part of the data frame. So if we are to change to Porky, it comes up with that information. And you see that, it's instantaneous. It's reacting to the user input. So that is the very basis of using Shiny. And I also have, in this one, I'll just copy and paste so we can move on to bigger and better things. Actually, I'll just skip You can see out on the GitHub there, I just included It's Shiny's, one of their tutorials that does a histogram. And it's the same basic layout, but it's a little more involved, and they have a default iris data set. So that's something you can check out later. But since I only have a little bit of time, I'd like to move on to Shiny Dashboard because that's where things get more exciting. So let me close out of here. And what's also nice about RStudio is the built-in terminal. So essentially, well, minus it's all messy. Here, you can just commit your stuff straight to Git. So I really like that. So let's move on. I'm just going to delete all of this. So Shiny Dashboard itself is more of it's a package that kind of, I guess, gives you a really good basis to start off of for dashboarding purposes. So I think if I show you kind of what it looks like initially, that's going to help. But for me, I love this tool. So the only thing added here, well, and there's a few things we'll check into later on, but essentially it's a different package that you include. And the basic layout is, instead of a fluid page like we were working with in Shiny, we're gonna have a dashboard page. And they just have some different methods that you call, to set up your header, sidebar, and body. So if we look at this, we'll see the default here. And apologize about the sizing. So this is your basic dashboard page. You have your sidebar. This is your main area. And it, even has that capability to expand and close by default. So when it comes to Shiny Dashboard, that's what you start with. I love it. It makes my life so much easier. But let's take a deeper look at what you can do with Shiny Dashboard. So the main thing is to get started, I'd say we'll take a look at, I'll just get rid of this, just adding some things to the sidebar. So normally with a dashboard, you'd break it up into different tabs that would display different information. So all we have to do here is, I'm actually going to give it a title. If I can type. And then we're going to add to the sidebar. So with the sidebar, we're going to give it an ID, just sidebar, basic. And I don't know if there's really, I don't think there's very stringent rules against double quotes versus single quotes. So it's probably preference. I probably shouldn't mix it as much as I do, but for time's sake, we are. But for the dashboard, you'll want to add menu items. So here we're going to have a home. We'll give the tab a name, which is kind of like the ID to allow us to access it below. And then built into Shiny Dashboard, they use font awesome icons. So any of the free ones you can have here just to add a little something extra. And then let's add one more menu item just so we can see the two different tabs, data. We'll give that an icon as well. All right, so did I forget? Oh, too many up here, I believe. Oh no, comma. There we go. Maybe. Nope, I'm missing one. Oh, I see. There we go. Okay. So with that small change, we see we now have a title. Oh, and I don't know why. Oh, I named something wrong. I forgot to call this a sidebar menu. Let me do that really quick. Just so that doesn't look quite, I mean, it still definitely allowed me to do that, but that's not what I wanted it to look like. Okay, let's try that. This will, and what's nice is it handles all the resizing for you. There we go. That Everybody, I'm back. Sorry about that. I lost my internet connectivity. So just to continue on, we were going to take a look at the dashboard body. So here, essentially, what's going to show up in that main panel area. So I'm going to add a header. So just keeping with the basics. And essentially, oops, no, don't want to do that quite yet. So what I'm going to do is, since these, are various tabs, we're going to have a tab items object down here. And essentially for each tab we have, so for home and for data, we'll have to call the tab item that will correspond. So we'll match up the tab name. So let's start with home. And then inside of here, Shiny Dashboard has a fluid row, which I like to use. You can also do a column-based layout, so it just depends which way you like to think, horizontally or vertically. So I'm going to do that, and I'm going to copy over this for just since I lost a little bit of time. And if you follow the Shiny Dashboard tutorial I put out there, it goes through, all of the cool things that you can do. They have all different sorts of widgets that are super nice for creating your dashboard. So here I'm adding an info box, which, is just going to have little pieces of data, and I'm just pre-populating it. So nothing too crazy. And I'm going to add one more fluid row here. So that way our home page has 2 fluid rows, and you'll see the difference between an info box versus a value box. It's more of a styling choice. And I might have added too many. Okay. This is the problem with copy paste is, yep, we're missing one. There we go. All right, so that essentially defines what's going to be on our home page when you click it. And then when it comes to the data tab, so we're going to add one more tab item, which I think is, yeah, right here. And this will correspond to our data tab. And we're also going to do 2 fluid rows here. What I kind of want to show in this is how the spacing works with a fluid row. I didn't really go into that above, but here we go. So essentially in Shiny Dashboard, you have the idea of 12 across, so you can divide up your row however you want, but it needs to add up to 12. So what we're going to add here is box. So we had specific types: info box, value box. The most general is just a box. It gives you a white box. You can put whatever you want inside of it. So we're going to do not a box plot matrix, a box. And we're going to do two of these. So like I said, you can put whatever you want here. There's some different styling you can use as well. So we'll give it a title. They have this idea of status, which kind of corresponds to colors, but a warning or an error, those type of things. And we'll give it an icon as well. And they have some preset colors too, which actually I did not want it to be that. Never mind. It's copying from the wrong place. We don't want it to be purple. We're going to do solid header, true, and collapsible. And there's all different sorts of settings. The docs detail everything nicely. But the main thing, we're going to say that there's a plot. This will be for future parts of the demo. But let me copy this in just, my time is getting close. So, and then we're going to give it a width. And this is what I was talking about, how the width has to add up to 6. So this one, or it has to add up to 12. So this would be a 6. The other one will also be a 6. And I am going to copy this for time's sake for our other box. Just something, similar. but instead, a warning status, no solid header, those sorts of things. And then the second Fluent row, I'm going to put, just for visual purposes, we're going to have 3 boxes just to see how that looks. Nope. Okay. And let's take a look at this. Won't make it pretty at the moment. This is really hard with the sizing. Normally you see it in a more normal way. There we go. Okay, so these are our info boxes versus our value boxes, just some different styling choices. And then on our data, this is really big because I made the, oh gosh. The sizing is just hard to see, but this was, one of our plots that we made collapsible. This was a warning without a solid header. This shows you, changing the background color, adding details. It's a little bit hard on my screen, but everything resizes automatically as well. So that's really nice. But let's see I only have a couple of minutes. So let me maybe, it's gonna be a bit of a jump, but I kind of wanted to show, I guess, just what the end product would look like. And then everyone could go check out the repo, and step by step I include the code there. So let me grab this really quick, because unfortunately I am running long. Okay. If I can do this. Just so you can see what we were going to eventually get to. So let me put it in here. Comment this. So essentially, I must have, it's annoying. Oh, it's because of this one line. Okay. Try one more time. And I think I made it so if you wanted to go follow the steps, it'll be easier. But essentially what we're going to have here now is it was going to expand upon, adding in some user input options, displaying a graph and a chart, that basic. So I didn't change the homepage at all. Nothing changed there, but the data. So conditionally, these would show up here, but they don't, they go away on the homepage. You have the option there, this is the default date selector, which is wonderful because I didn't have to build it myself. The graph updates automatically. We can change the type of graph as well as view the raw data and download it. So I know that was a bit of a jump, but unfortunately I do walk through in the repo adding, each of these step by step, which I think will make it nice. I'm also going to push after this call a modularized version, because as you build more and more, if we had 10 tabs here, you obviously don't want them all in one single app file. So I was going to push out a modular version because that's something I've learned lately, and it makes it much simpler to organize your code that way as well. But I think I'm I'm out of my time. Yes. Okay, so what was the hardest part of learning Shiny? I think what I had to get used to is how to handle the reactivity. I didn't cover it, we didn't get to it, but there's ways to isolate if things depend on each other, as well as passing things. So when it's all in one file, it's not as big of a deal. But when you start wanting to break it up, being able to pass the values back and forth correctly and find ways to conditionally do things here but not there, I think that's been the hardest part. And then when it comes to R, I've really enjoyed using it. I'm traditionally, I was a Java developer when I started. I've been doing a lot of node work. And so going to R, it does have a few things that are syntactically different, but I was able to pick it up pretty quickly, I feel. I don't think I'm quite there with all of their data structures yet, but I'm learning. But I think it's a really fun language, and for any sort of data analysis type of work, it's amazing. So I'm really excited. It's been fun learning something new every day using it. Yep. Yeah. So, like I said, my name's Megan Kostick. Let me show that URL one more time if people need to screenshot. So yeah, just Kostick M, the Shiny dashboard intro broken up. And I'll be adding the modular piece as well after this. So, and if you have any questions, just feel free to follow me or message me on Twitter, Kostick Megan. You'll find me out there. So thank you everyone for listening, and hope you go try out Shiny and Shiny Dashboard.
Hey, everybody. So my name is Gabriela de Queiroz, and I'm so excited for this event today. So many great talks. So I'll be watching all day long and learning from all of you. And so let me introduce myself first, and make sure that you know a little bit about what my team does, what I do, what I've been doing for the past few years. So I work at IBM in a Center for Open Source Data and AI Technology. So it's called CODATE. And I'm a mix of like developer advocate and engineering and data science manager. I'm also the founder of Our Ladies. I don't know if you know about Our Ladies, but now at least you know about R, which Megan did a great job introducing Shiny. And I'm a really, I love Shiny. I think it's so wonderful, easy to use. And R is a programming language that was developed by statisticians 25 years ago. And it's been growing and growing, and it's being used by data scientists. It's similar to Python in some ways, very similar to Pandas. Pandas is very similar to R. And there are several packages. You can do mostly everything with R. And Our Ladies is an organization to bring more diversity into the art community. And it was founded in 2012. And we have chapters all over the world, in 45 countries and more than 145 cities. I'm also the member of our foundation and our consortium. And I don't have much slides today. I was thinking about like uh, some conversation and some chat, instead of like having a regular talk. But I'll be talking a little bit about the team itself. So let's go to the next slide. So as I mentioned, CODE, which stands for the Center for Open Source Data and the AI Technology, it used to be called Spark Technology Center, but then we relaunched it to reflect our mission on data and AI. So we are located in San Francisco in a very pretty building, on Howard Street. And we have like several projects. And the idea is to improve the AI lifecycle in open source. So if it's not clear, everything that we do, it's open source, it's free and open to everybody. Some of the projects that Codate has been working on as a whole organization, we have the Model Asset Exchange, which is my team is working on that. We have the AI Fairness, Fabric for Deep Learning, Jupyter Enterprise Gateway, and others. So you can check it out. If you go to codate.org, you can check it out, all the projects that we have. As I mentioned, the main project that we are working on these days is the Model Asset Exchange. There are several ones that are running in parallel. On top of Model Asset Exchange, there are some people in the team contributing to TensorFlow. So we have a good presence on TensorFlow, the core framework. And the Model Asset Exchange is a place for developers and data scientists to find and use free open source deep learning models. So we have deployable models and trainable models. Let me go to our main web page so you can take a look. Let's see. I can show you a little bit what we have. Yeah, so if you go to our web page, you can see all the models that we have, from all the deployable ones here, and all the trainable ones. So the deployable ones are pre-trained models that we did all the processing of like researching, finding the license, making sure that the license is good to use, making sure that the code is also like up to date, there is no bug, and then we wrap everything in a Docker container so you can use all these models. The only thing that you need is the Docker container. The trainable ones, you can train, use your own data, using platforms such as Watson, for example. Another interesting thing, if you are totally new to deep learning, you can try the tutorial. So we have a step-by-step on how to use all these models, or some of them. And you can create also like a web app, for example. So later today, my colleague, Sai Siruti, she's going to give a more deep dive introduction to Max, where we call the Model Asset Exchange. And she'll be showing a demo, a live demo. So she's much more, she's going to show like live demo, which I was a little afraid of showing, but she knows how to do it better than I would say than me. So what else? If you are interested, you can go to Google, then look for Model Asset Exchange. Over here, the first link you're gonna see, it's our link to our models. There are several tutorials that you can look it up, several videos, articles. If you are interested in how to use that, I would totally recommend you to do a quick search or go to our website. As I mentioned, if you go here to codate.org, let me make this a little bit bigger so you all can see. There are a lot of like good content over here, some blog posts talking about all the projects, the feature projects that I mentioned before. You can go in and then learn and use how to use the project, in this case, this model. What else? I don't have, I don't know if you have any questions so far. But as I mentioned, I didn't have much slides to talk about, but I can talk about, I was planning to talk about R, and I can talk about R and the ladies forever, but I don't want to manipulate this time to talk about Our Ladies. And one interesting thing about Our Ladies and the R community in general is the R community is well known for one of the most inclusive communities throughout all the open source communities. And interesting stuff is if you go to Twitter, for example, and you look for the rstats hashtag, you can get a lot of knowledge just following this hashtag. Like there's so many things going on. People asking questions. It's kind of like a Stack Overflow, but in a different way. So people asking questions, sharing knowledge. So it's a good way if you want to get, if you want to get into R, and if you want to keep up to date, because like every day there is something new in R. So it's a good way for you to keep up to date with the new libraries and the new resources and tutorials. So Amara is asking about the best resources for learning R. Let's see, the best resource. Well, I would say that RStudio has a bunch of good tutorials. And let me try to find out. Yeah, so like they have some blogs. I would say depending on whatever you are interested, you should go over here. They have also like an education, like an education piece of RStudio where they, oh, over here. Yeah, so they have like some webinar videos, online learning, in-person workshop, and the community. The community is pretty cool because it's the community RStudio. It's a platform for you to ask questions. It's similar to Stack Overflow, but friendlier. So like kind of like judgment free and very welcoming. So if you have questions, I would totally suggest you to come over here to RStudio, community.rstudio.com, and ask your question. There are a lot of, like, again, several interesting resources. You can look for the tag, and you have like all the package authors over there answering questions as well, other people in the community answering questions as well. So this is one of my favorites, is the community RStudio. So this one is another cool stuff. It's the cheat sheet. And like if you are trying to do some data wrangling, for example, you can go over here and find, like, let's say, how to do data transformation. So like this is like the main functions that you can use to do data transformation, or like how do you import data in R. Like this, again, this is like the main commands that you can use. Another one that I really enjoy is the deep learning one. A lot of the deep learning commands are very specific and a little bit different from the R syntax. So that's another one that I have. And some of them I have printed. So at RStudio conference this year, they gave us kind of like a book with all the cheat sheets, all those cheat sheets in a grouped way. So we have all printed, and every now and then I go there and then I check because it's impossible to remember all the functions, all the arguments on the top of your head. Yeah, you can do in R, you can do deep learning, you can do all the data manipulation stuff, all the data modeling, machine learning, pretty much everything. As Megan mentioned, You can connect to databases. You can create presentations within RStudio. You can use GitHub. Oh yeah, that's a good thing. Let's see if I can show this real quick. The RStudio framework, or the IDE, sorry. So you don't have to leave RStudio once you are working over there. So let me show you something real quick. So like in RStudio, like there are all those, let me make this bigger to make sure that everybody can see that. So you have all these tabs over here. So this is the console, then this is the terminal. You can use as the regular, terminal. This is if you want to run any jobs. And if you go over here, you can find all the files. If you're uploading something, it's going to show up over here. All the packages that you have installed, the help, and the viewer. So if you go to this other tab, you have all the environment variables. It's going to show over here. In this case, it's empty because I didn't run any script. You have the history of all the commands that you ran during this session, and connections to database. And then one of my favorite one is the Git. So like, let's say I was working in a Flex dashboard. So I was working in a poster to present. And let me go over here. So I have a RMD file. RMD is the R Markdown. Oh, someone is asking about the IDE. No, this is not Eclipse. This is RStudio. It's the RStudio IDE. So you can come over here. This is a R Markdown file, and then I can knit. I didn't try this before, so I hope it works. So what it's creating is creating a poster, a HTML. And this was for a conference where I was planning to present a e-poster. Let me see if I can show over here. Well, this is yeah. So this is a poster that I made for the conference. It's an e-poster, so I did everything inside R. And if I come over here on this tab, for example, I'm on this branch, and let's see if I changed anything. No, but let's do a change over here. Let's remove this R, this A over here, and then it's saying over here, oh, you modified this file. Oh, cool. So I can either come over here and see what I changed. You can see like the changes that I made. So before we had the A tour, and now I removed the A, so it's tour inside. And then let me open this up so you can all see. And then you can add a commit message. This is a test. And then you go and commit. If I close over here, it's saying, oh yeah, branch is ahead by one commit. Then I would push. I'm not going to do this because I'll mess things up. But like, you can also see the history of all your Git commits. And so I really enjoy that. So you can create a new branch, again, within RStudio, and do everything inside the UI. So I mentioned you can create, in this case, I created an e-poster using the Flex dashboard package. I can do, if I come over here, file, I don't know if you were able to see this, but when you go to create a new file, you have a few options. You have options to create a documentation, a R presentation, a regular R script, a notebook, a R Markdown, a Shiny web app, a Plumber API. So a lot of options again. Let's see. Yeah. So and then you have some add-ins. You can run a blog down. So I have a website. In my website, let me show you. It's all in blog down, and I did inside R. So let me give you just a flavor of like how it looks. So this is my website, and everything here I did inside R using this blog down package, which is you can use the Hugo framework to create your website. Well, let's see what else. Yeah, so if you're interested on Our Ladies, again, I totally I would recommend you to go to the website and look up all the chapters that we have. So the first one was San Francisco. So if you come over here, you uh, you click on San Francisco, and then it's going to redirect you to the meetup.com page. So you can come over here, join the group, and all that. One cool thing that I want to show is, since Megan was talking about Shiny, this is a Shiny app that we developed. Let me make this a little bit bigger again. That we developed to kind of like track all the Our Ladies chapters. So this is made in our Shiny dashboard, and we use a Meetup API, a package that we also developed inside Our Ladies called Meetup R. So it's a package that goes and get all the information from Meetup and then display on this dashboard. You can come over here and say, this is Our Lady San Jose, was created in this date, and we have this X number of members. You can also come over here and see the breakdown by region. So you can come over here and see USA. The latest chapter that was created was Houston. Like in Latin America, for example, we have 29 chapters. La Paz was the latest one created. And if you are curious, you can come over here. We have the source code available for you to take a look. And since I still have time, let me show you real quick. So this is the app. The same kind of like similar files that Megan was talking about, like the app one where you have the UI piece and the server piece. It's all over here. The only difference from what she presented is we have this additional file where I go using the Meetup R package, and then I get all the information that I want and do some data manipulation over here. But that's pretty much the same what she had. So you can expand the Shiny. You can expand and do things that it's related to your use case. There are other projects inside Our Ladies. We have the package, as I mentioned, the Meetup R package. If you are interested, you can come over here and then do a pull request or open an issue. Also, I would encourage, if you are a first time or a beginner on the open source land, we have like a few projects here you can start contributing. And sometimes we try to do the work of like labeling as a good first issue. And all the Meetup presentations from all the chapters are in this repo. So if you want to use any material, you are free to use. We have a blog as well, the Shiny that I mentioned, some presentations around Our Ladies, and other blogs. All right, we have 3 minutes to go. So if we don't have any other question, I don't think so. I don't see on this chat. So. All right. Okay. So I'll be watching all day long. So don't miss all the other talks that we are going to have. So after this one, we'll have Open Standard for Predictive Model Deployment by Svetlana Levitin. And then after that, Jerry Jody Burks will be back talking about Coffer Code, and there are a whole day of interesting talks. So I hope to see you on chat, and have a great Friday.
Hello, everyone. I'm Svetlana Levitan. I'm a developer advocate at IBM Center for Open Source Data and Artificial Intelligence, and also PML Release Manager. And today we are going to talk about open standards for predictive model deployment. So we will talk briefly about machine learning in general and model deployment in particular. We will talk about three open standards for machine learning deployment, and we'll see how they're used in open source and some IBM products if we have enough time. So in general, machine learning is now a very hot area, as you probably know. It's an important part of science, which is now everywhere. And as you know, machine learning is used in many areas of life, from weather prediction to self-driving cars, etc. Well, here we are going to talk about similar, probably. You may have heard about models like clustering, linear regression, logistic regression, decision trees. Unfortunately, we only have half an hour today, so I cannot explain all those models in detail, but you can find lots online about all those models. And of course, neural networks are now the most popular ones, and especially with deep learning. Well, here on the right, I have a picture of a deep learning model, which is a very large neural network. But many models nowadays are much larger than this one. So if you have questions about those things, ping me, and I'll be happy to discuss those things. I love machine learning in general. Well, actually, machine learning field is not just building models. It's usually a whole process where you start with collecting data, and sometimes it's not easy to find appropriate data, and the data often is in a wrong format, so you have to take the data, find the data, put it in the proper format, clean it, figure out what are the predictors that you could use, and probably transform somehow the predictors. Then you build a model, and there are many different models that you can try in different parameters. And finally, okay, you found a good model that you can use for your data. Is it all? No, it's just because once you build your model, you need to find ways to deploy the model so that it could be used to predict for some new data. And that's where you get the return on your investment on all this process, machine learning process. And once you deploy the model, you also need to monitor it and update as necessary, because a model could be working very well at one point, but then later the trends in the data can shift, and you would that model will not work very well anymore. You would need to update it. So you have to monitor and make sure it's still good. So today our main topic is this model deployment step. And very often model deployment is not easy as you might think, because very often there are different teams who are developing the models and deploying them into production. So data scientists or statisticians would develop a model using maybe Python, R, or some kind of software. But then for production, the models would need to go to application developers or some IT personnel who would need to deploy them in a database or in some streaming environment. Who knows? So there are different environments, different languages. Very often it's important version of the language you have, etc. And another thing is, I mentioned the data preparation step. Very often it's like 80% of the whole modeling is spent in data preparation. And if you have built your model on prepared data, then when you score your model, you also need to prepare your new data in the same way as the original data. Otherwise, your model will not work. So keeping all these data preparation steps along with the model is an important step in model deployment, and often it's not. So you can see that there are a number of challenges. Well, fortunately, back in 1990s, Professor Robert Grossman, who was then a professor at University of Illinois in Chicago, and now he is a professor in University of Chicago, which is much better school, he created this data mining group, a group of companies working together on open standards for predictive model deployment. And the first standard that was created by the data mining group was this predictive model markup language, or PMML. So as I mentioned, it is an open standard for XML representation, because in the 90s, XML was the main way to represent things. And it has been developed by the data mining group since about 96, I don't know exactly. I know that the first mention of PMML was in 97, where the version was 0.7. And since then, PML has been developing a lot. Many things have been added to it. And now, de facto industry standard supported by over 30 vendors and open source organizations. And I have been working with PML for many years now, and currently I'm release manager for the latest released version is 4.3, and we are hoping to release 4.4 sometime soon. And you can find all the documents for PML at this link, dng.org/PML. So what is a PML? Well, it's kind of XML file which describes the data and the transformations that you apply to the data and the models that you want to represent. And I could go into details on this a lot, but of course we don't have that much time, so I'll just briefly describe here. For example, the transformations. Well, there are norm continuous, which is piecewise linear transformation, because very often when you have input, continuous input data, numeric data like age or price of something, etc. If you want to build a neural network model, for example, you need to normalize that data to make it into like -1 to 1 range or something like that, or at least subtract mean and divide by standard deviation. So all those are linear transformations, of course, and they can be represented using the element norm continuous. The norm discrete is used when you need to map a categorical field into n dummy variables, or it's called one-hot encoding. So norm discrete is used for that. Discretized element allows you to bin a continuous input. So if you have some models that only takes categorical predictors, but you have a continuous predictor, you can apply binning and record it in discretize. Then you can do that. And in map values, you can map certain into values of another categorical variable. And there is a pretty good set of functions that we have. There are built-in functions, as well as users can define their own functions building on top of all those built-in functions transformations. And there are also aggregations and some other transformations. So in PML 4.3, which is, as I said, the latest released version, we have 16 different plus we have a mining model, which is a way to combine several models together into an ensemble, or maybe some kind of segmented model. All those can be, or model compositions can be done using mining model element. Any questions so far? Okay. So here I want to show you some examples of PMML to give you a better idea of how it looks. So this was a small example of PML3, of a model, actually, where you have iris data. You know, the iris data is a famous data set found in University of California, a set of data for machine learning. The data has 3 classes of iris flower, 50 cases for each class, and there are 4 continuous predictors: sepal length, sepal width, petal length, petal width, and very often the goal is to build the model which would predict the class of the flower from 4 measurements. And here I have a picture of a neural network that I built using probably SPSS product. So since I have 3 classes for the target variable, on the right I have 3 output nodes, and I have 4 continuous predictors. Those are inputs here on the left. And plus there is always a bias unit, which just produces value 1. And in my neural network, I have 3 units in the hidden layer, as well. So all those connections have weights associated with them, and the values of those weights, basically, plus the activation functions on the hidden layer and the output layer, all this together defines my model. So in PML, first I have data dictionary, which describes my data. So for categorical fields, I have the list of categories, and for continuous fields, I just that they are continuous fields, and the data type is double. And then I have this transformation, and here at the bottom I'm showing a part of transformation dictionary where I have those normalizations that we discussed before. So I have norm discrete for the target variable, which connects each of the target categories to one new field, which will be I'm sorry, new field corresponding to one of those output units. And for continuous field, I have this normal linear so that we get good inputs. And then here I have a piece of the neural network element which describes the model itself. So you see that function name is classification because my target variable is categorical. And the activation function, the default activation function for the network, hyperbolic tangent. And mining schema describes my predictors and my target, and predictors are those four, and the target is the class. And then I have neural inputs, where all my inputs are described and connected to the normalized that we had defined previously. And in this part of the neural network, I have a neural layer. This is neural hidden layer, and then here we have output neurons in the output layer and the corresponding weights. And then neural outputs element describes how these neural outputs are connected to the target variable. And here I have another example, which is for a decision tree model. In decision tree, as you know, and then there are splits. So in PMML, we have a node element describing each node, and each node can predicate. For the root node, it's always true, but then for the children of root and for nodes, the predicates are specifying which conditions are used for this. So in this case, my predicate, simple predicate is length is less or equal to 2.6. Distribution describes how many records from each class belong to this node. And as you can see on the of the decision tree, if the petal length is small enough, then we identify all the iris setosa cases. But if it's larger than 2.6, then we have all those other cases, and then we split to the children nodes. Any questions so far? Okay, thank you. So, well, as I mentioned, PML is used in many different companies and products. And here I have a list of companies or open source packages that support PML. You can find this list on the DMG website under products.html. But I found that this has not been updated recently, so it's slightly obsolete. So I think in fact, actually, there may be more companies and packages supporting PML in this list. Now, I wanted to show you how to use PMML using some open source code. There is an open source package called JPMML, which was created and is maintained by Vilu Rusman. This guy lives in Estonia, and he has created a lot of code for supporting PMML. There are sub packages for many different open source kinds of stuff. So in this case, I show how it's Python with the scikit-learn package, which is now very often used for machine learning. So in this code, we just, and I did not create it all this example on Stack Overflow. So I'm not taking credit for this, I'm just showing how it's actually could be done very easily. So here in the top part of the code, we just build a classifier based on the iris data. And then at the bottom, we just create this data frame mapper, which could describe the transformations applied to the data. If you have transformed your data before you actually build the model. But in this case, we did not transform the data. So basic mapper. And then from sklearn to PML, you import that function and use it very easily. You just specify your model, your mapper for the transformations, and the file where you want to save PML. And that's it. You get your PML out of the model. Provided, of course, it is a model that is, I believe, most widely used models are supported. And here is another example how you can use PML in R. In R, there are packages PMML and PML transformations. I believe those packages were created by my colleagues in the data mining group who worked at the company called Zementis. Now that company was acquired by Software AG. And yeah, so as I heard somewhere, it has like 17,000 packages. Well, the list of packages that are supporting PML is much shorter. You can see it here. So it's what, a dozen or well, less than 20 models that are supported by PML. And also in JPML, there is some code that supports some additional packages. I'm not sure how many. But in any case, if you want to get involved, I'm sure there is a lot of work to add support for more R packages if you want to work with open source and machine learning. So you may want to look into this if you are looking for an open source project. And here is actually how you use those packages to create PML. Again, it's just like one line of code. So you just need to import the library for XML and PML, and then you say, okay, save XML and PML of a model, and then you write the file name, and you're done. So it's very easy to create PML out of those R models that are supported. Well, at IBM, both IBM and SPSS were among the founding companies for the data mining group. As I mentioned, that was in the 90s. And SPSS actually started as a statistical package for social sciences, which was a product that started 50 years ago, in 1968. And it was acquired by IBM in 2009. Oh, I guess this year it will be 10 years now. And well, this product is still, well, I don't know how many software products can say that they're 50 years old, but this one is. And the last release was 25 in August 17. And I believe there is work on the next release going on now, but I don't know when exactly it will happen. And there is also subscription option where you can get all the latest and greatest just by using subscription. Okay, so yeah, so this in this statistics product, which I like very much because I worked with it for many years, there is a very easy to use many statistical features. And another product that we have is IBM SPSS Modeler, which was originally Clementine and then was acquired by SPSS back in '98. Okay, in both of these products, we have very good PML support. And here I have a list of models for which you can export PML in those two products. And as you can see, those lists are pretty long. And it's also easy to score a model in PMML. To score a PML model inside those products. So here I'm showing scoring wizard in statistics, and you can go through several easy steps and you get your scores very easily. Another product which supports PMML and is now growing in popularity is Watson Studio, which originally was called Data Science Experience. And Watson Studio is an amazing product that is included open source stuff that you would want to use, like Jupyter and RStudio. And it also includes SPSS Modeler and many other tools, and all those open source things like sklearn, Spark, etc. Plus a lot of deep learning stuff. So, and PML is enabled. So you can get PML from Python, as we discussed, and from R, and also from SPSS Modeler. And then you can deploy PML models again in flows, or the flows is SPSS Modeler flows, or you can also deploy in Watson machine learning. So here is an example of Watson Studio flows, which was based on the modeler stuff. So the the flow looks slightly different from what was in modeler, but essentially it's similar. And then here I show to deploy a PML model in Watson machine learning. It's very easy to open a PML file here, and then it gives you those different code snippets, how to integrate your deployed model in curl, Java, JavaScript, Python, Scala. And you can also have examples to see. You can test your deployed model using such a simple graphical user interface. So to summarize about PML, it has lots of benefits. It allows seamless deployment and model exchange and transparency, and fosters best practices. Now, another open standard that was developed by the DataMine group is a portable format for analytics, PFA. And the reason it was developed about 5 years ago or less was because in PML, everything is very good, except if you have a model which is not supported by the standard, then it's really difficult to, well, you can create extensions, but then it's no longer portable. So PFA is kind of a different approach. It's JSON based. So it was developed by this guy here, who is called Jim Pivarsky. And so PFA is JSON based, and it's kind of a small programming language. And this guy shown here is Nick Pentrias, who is also working with Codei, although he lives in South Africa. And he developed a package called ArtFark, which provides PFA export for Spark ML models. And we did a joint poster with him recently at a conference, which was quite popular. And here is a simple example of PFA. So it looks very different from PML, as you can see, but it can do a lot of stuff. Okay, now, yeah, and there are several open source packages, again, supporting PFA. Maybe not as many as PML, but quite a number, and there is a lot of interest in it. And so there is a lot of work to do as well. So let me know if you are interested in working on PFA. And there are other model deployment formats. For example, there is Pickle in Python, which is not so portable or open, and you can have problems if you saved a model in Python in Pickle and then you try to use it later when there is a different version of Python. I'm not sure if it will work very well. And there is mlib, which is not really standard, and it's kind of binary. Now, of course, as I mentioned, deep learning models are used everywhere, and there is a lot of interest in exchanging those models. And so Microsoft, Facebook, not that long ago, came up with this Open Neural Network Exchange, or NNX, which is pronounced as ONNX. And that is a new format that is now very actively being developed. And IBM is also working on it and contributing actively to it. Because there are different deep learning frameworks, PyTorch, Caffe, Cognitive, Toolkit, MXNet, etc., TensorFlow. And currently, ONNX has a lot of support for most of those packages. And with TensorFlow, there is still active work going on, which both IBM and Microsoft are working on. And there are several different working groups now for ONIX, and we're all actively working on this. Actually, there will be a meeting next week about ONIX, so there is a lot of work going on. So ONIX seems to be now the de facto format for the deep learning models, because unfortunately PML and PFA did not have support for deep learning. We are trying to find ways to support it, but now we have ONIX, so it's not very clear exactly how to do it. Well, I'm trying to make sure that in PML we already use the ONIX format for internal representation, because otherwise it's could be confusing and a lot of extra work. Because there are so many different deep learning frameworks. I didn't include here, but there is also Chainer developed in Japan, and there is Paddle developed in China. So there is a lot of work. Well, there are also Docker containers. This is well, not open standard, but it's an approach that many companies are using. And our own model asset exchange, this is a set of models which are ready to use open source pre-trained deep learning models. This is maintained by my group Code at IBM. And those models currently are provided as Docker containers. Okay, so the conclusions are that model deployment is a very important part of machine learning lifecycle. And the data mining group works on PML and PFA, and PML seems to be most widely used, but PFA is also growing. And ONIX and Docker are used for deep learning. Any questions? Okay, thank you for your attention. So here I have also IBM now sponsoring this Call for Code initiative. There was one last year in summer, and now we have a second version. So this Call for Code is an initiative where developers, designers, and data scientists are invited to work together in teams to create some kind of application, maybe cell phone apps or some devices, whatever they can come up with to help people affected by natural disasters. And I think it's a very good initiative. And if you are interested, please go to callforcode.org and sign up and participate. And last year, I believe the first place, or actually the top 5 teams got money for the inventions, and IBM now is helping them to actually implement the inventions and to put them into use in practice. So this year, again, we have it, and let's participate. Thank you.
Hey, everybody. I'm back again. I'm Jody Burks. I'm a developer advocate with IBM, and I'd like to talk to you today. We're going to switch gears a little bit. It's not going to be super technical, but it should be pretty exciting. So I'm talking about the call for code. Now, we did this last year, and it was a huge success. It is a way that developers can come together and create solutions for natural disasters, for recovery, for different stages of disasters. And it's a really great thing. I'll let you know a little bit later and talk why I am super excited about this. But I want to introduce it because some of you may want to get involved. And then after we talk a little bit about call for code, I'll tell why this is very important, or this is very important to me. And then we're going to go into a little bit of design thinking, focusing really on the creating empathy with disaster victims. Okay, so we could talk about many people that are involved with disasters, whether it's first responders, community organization leaders, or volunteers. Because of time, we're just going to talk about what's going through victims' heads, what are they feeling, and the idea is to really get a better picture of who you are designing solutions for. So let's get started. So we can't prevent natural disasters from happening, but with the call for code, we can really help lessen that impact. We can really help people's lives, help people recover, either help people get a little bit better prepared or help with recovery efforts. So there's a lot of things we can do with this. Why is this important? Well, natural disasters they're increasing in numbers. I mean, there's over 800,000 people have lost their lives just to earthquakes since 2010. That's not counting hurricanes, wildfires, tsunamis. There's tornadoes. There's a huge number of different types of natural disasters. With wildfires, around 17 million acres were lost just in the last couple of years in the United States to wildfires. The numbers and the stats go on and on. These are some of the world's greatest challenges, and it's really exciting to be able to play a part in helping these not have quite so much of an impact. It's still going to be a pretty big impact, but we can help solve some of these challenges. At the same time that these are the natural disasters are increasing in frequency, the power of our developers is growing as technology has a larger impact on our society and is finding its way in every aspect of our existence, from our smartphones, tablets, everything. So there's now over about 20 million developers out there with an amazing array of skills, right? And this array of skills exist. We can put that to use, saving lives and livelihoods in their communities, global communities, everywhere. So because every place on the planet is affected by natural disasters. If it hasn't, it's probably a matter of time, right? So this is hugely important. The theme for our call for code this year is really focusing on that health of people and communities. Last year, we launched with a $30 million 5-year commitment just from IBM. And so we're in year 2. And so very excited about that. What's at stake here? We're talking about the Call for Code Global Prize and the support that's going to come with that. This year, we are helping implement, through our Code and Response program, one of the solutions from our winners from last year. I'll talk about them in just a second. The winning prize is $200,000 cash. And you're getting support from the Linux Foundation as an open source project. You're getting the opportunity to present to NEA and the official Call for Code VC film. And also, and this is the important part, this is part of the Code and Response. You have the opportunity to have your solution implemented with the IBM Corporate Service Corps. So you're getting the support to really take that product that you have designed and really implement it. to really help people. There's different ways for people to be involved in Call for Code. You can join as an individual developer. You can join as a team. You can be a supporter, different affiliate organizations, or just a sponsor. Anything where you can do to get involved is certainly welcome. Now, the timeline at the bottom, the submissions are going to be opening up. I think when I checked the website, it said the 25th of this month. And then development can continue, and people are going to submit their projects up until sometime in July. And then we'll end up judging them August, September, in that time frame. And the winner's going to be announced in October. So last year's winners, Project OWL. They came up with an IT and software solution. If you've heard of the little cyber ducks, this is that project. So very exciting. The solution helps keep first responders and victims connected in a natural disaster. And I've posted a link, or there should be a link in the chat if you wanted to see the code and response little video. It's there. You can also search for Project OWL and see all the really exciting stuff that's going on. You can follow us on Twitter at IBM Developer. There's a lot of developer advocates that are involved in this. It's very important to us. So these are our runners up. We have solutions that focused on wildfires, engineering advice, financial services, and then collaborating between volunteers and relief workers. So there's a huge range of different solutions, tons and tons of just brilliant ideas. Everyone that contributed last year, thank you so much. Just amazing ideas. So these are some of our runners up. And what we're doing this year is we're going to focus on health and well-being of communities. So during a disaster, the idea is to reduce the risk of disease. You want to address mental health services and options there, because mental health, and we're going to talk a little bit about this in a little bit, is really something people don't think about when we're designing solutions. When you're in a disaster, it's one of those things you just kind of take for granted, right? So we'll talk about how to design, or some of the factors we want to keep in mind when we're designing solutions later in the talk. There's different events that you can participate in. Again, you can contribute individually, but we're also going to have some Call for Code hackathons around the world. There's university events, open source ecosystems and events. And then if you work for a company, then your company may also have its own Call for Code event. So there's a ton of different ways to help out and get involved. So why participate? We want to build on that success, right? Last year we engaged about 100,000 developers, and they not only took part in the Call for Code, they also learned IBM technology, but they also joined the community united in a goal of addressing natural disasters that affect people. And so it's a really great way to contribute to the world. It makes you feel real good. So we're going to get to the part about why this is important to me in particular. So what would you do if you lost everything? And I mean everything you own. So do you know anybody it's happened to? Congratulations, you just met somebody. Courtesy of Hurricane Harvey. So I'm in Houston, and we were flooded in Hurricane Harvey. We were not in the least bit expecting any of this from this thing. So this hurricane, normally hurricanes, you see their effects for a few days, right? Well, this thing comes in, it blows into the coast, it comes back out, it comes back in. It didn't know where it was going. So that is a combination of different physical meteorological factors. But one thing that's important that I want to point out is that hurricanes, we might actually see more of this. Hurricanes are starting to slow down, and as opposed to just powering through, they're slowing down and they're dumping tons of rain. So that's one thing that's a trend that's been reported recently. We're going to see a lot more flooding events, unfortunately. And this happened about a week after we set up our child's nursery. I was heavily pregnant at the time, but you can see the before and after pictures. We had almost 3 feet of water, depending on where you were in the house. It was enough to actually pick up the crib and move it. We did not do that. This was after the waters were sort of receding. And we got out by boat with the pets, of course. And that's me on the right. You can always, you just really dress really exciting when you're thinking about trying to get out in the boat, right? It helps to have a sense of humor. If you don't have your sense of humor, you don't have anything at all. So this was actually our neighborhood. One of these houses is mine, before the floodwaters actually got even higher. This was not what I was expecting the day before. So what we were thinking the day before was that as the water was coming in, okay, it's gonna go down. Houston has systems for draining large amounts of water. We're so close to the coast. We've got bayous and Ship Channel Bay. We've got a lot of water in our area, right? So we're looking outside going, okay, our reservoir control areas, they filled up, but they're going to start going back down. We look at the flood gauge. As the water is going down in the flood gauge, we thought, okay, great. So the car was gassed up, ready to evacuate if need be. We had food if the electric went out. We had potable water. And then all of a sudden, in these pictures were taken about where this red dot is, the water starts rising. And it's not going away anytime soon, and more rain's going to be coming in. So you can tell the water actually came in much more as time went on, and resulting in the pictures you just saw. So what's this got to do with technology and call for code? I want to talk a little bit about designing for natural disaster victims. What are they thinking? What are they feeling? And it may not be what you think. Now we're going to talk a little bit about design thinking. This is a way of helping us. It's a process of different steps. It allows you to solve complex problems. It may be in a complex environment, but the idea here is to focus everyone's thinking on the user experience, because you want your user to actually use your product, right? If your user cannot use your product for whatever reason, maybe their mental and emotional state, maybe the technology issues, then your product is going to fail. So you have to keep the user experience in mind when you're designing anything. We also want to encourage cross-functional collaboration and speed the process up. I'm not going to go into detail as far as the different steps, but just briefly, it starts off with a problem. You want to have the focus of the user. We use empathy maps to really get that picture of what's going on for them. And we get an idea of their current situation. We come up with ideas to fix the pain. Then we prioritize, well, which ideas are good, which ideas are probably already taken. Where is our space that we're able to go in and start solving problems? And then there's some storyboarding at the end. For time, again, we're going to focus on that user experience. So I'm not going to use a whole bunch of sticky notes. We're going to go slide by slide, just different scenarios and whatnot. So the first thing I want to start off with is your disaster victims. They may or may not know something is coming. They may have warning, they may not. In the cases of hurricanes, a lot of times people do have warnings, and they take prepared steps to get prepared. But in any case where you're preparing, you have your knowns and your unknowns, and the unknowns are definitely what gets you. So despite any preparations, all preparations that you're planning, you're going to be unprepared for something. In our case, it was basically the wall of water that came from the west side of town down our creeks and flooded the neighborhoods along the creeks. So you can see I had the our vehicle gassed up. It was pointed ready to go out of the driveway. Unfortunately, it didn't get so far out of the driveway because water came up on the storm drains on either side of us and flooded the street, so we couldn't actually get out. Everyone on our side of our street, we lost all of our vehicles. The gas can, by the way, that's the gas can for the generator. So there's gasoline in there. I couldn't run the generator. We had power, but you couldn't run the, I mean, where are you gonna set a generator, right? To fuel up. That's some safety concerns. We had potable water. And one of the mistakes we made was that it was in a very large container and that it was very difficult to lift. So that's it sitting on a step in flooded water. Would you drink that water after it was in that container? I wouldn't. So there's always something, the best laid plans, something is going to fail. So just being prepared for that is one thing that people need to understand. So when we're talking about our users, we want to focus on a few different things here. What are they feeling? What are they thinking? What are they saying? What concerns are they voicing? And then what are they doing? So it's best to put yourself in those shoes. What would you do in this situation? Probably not what you expect, because stress responses affect people in ways that you have no idea that it's going to happen to you. There's a few different stress responses. For example, some people go into survival mode in a crisis. Some people just flat out panic. Some people have a state of mental paralysis, and it's like, hello, they're stuck. Some people they have flat out shock, and some people you can't find them. They have gone and they just shut down. There's people that they can be out in the middle of the ocean in a life raft, and their body just shuts down and they're napping. That's not exactly the smartest thing to do in a situation like that, right? You want to remain alert, but physiologically, you're going to shut down if you have that kind of response. The thing is, you have no idea which one is going to affect you until you're in that crisis. People behave very differently, very, very differently in a stress response. It's an unfamiliar environment. They've got confusion. They're disoriented. And this is going to be true whether the disaster is unfolding quickly or slowly. So there's some really good articles that I found that were very well written. One of the quotes from those, and I'll show those on the next slide. It's being in a situation where your life is in danger increases your emotional arousal, and high arousal causes people to limit the number of alternatives that they consider. So that can be bad when trying to determine a course of action, since you may never consider the option most likely to result in escaping safely. And I really can't state that any more plainly. People will get stuck because they're getting flooded with emotions, they're getting flooded with different signaling in their body. Their systems are completely overwhelmed. So they're not going to use your technology the way that you think they're going to use it. That's the main point. Case in point, just a visual. People were out. You're probably wondering what that massive something is over in the corner. In the US, we have things called fire ants, and they float. They make little rafts and they float, which is incredibly scary because something that size can kill a small child if they're in the water at the same time. And people, when the streets flood, a lot of people say, "Oh, great! It's you can go swim in the street." They're not thinking, "Oh, gee, this is actually a problem." It's back to that survival type thing. They're not going to make the right choices. So swimming when fire ants can potentially kill you is just an example of that. Here's the links. These are just a short list of some of the ones that I found that really dig into the psychology of disasters. A couple of these are BBC articles. They're very well written. I definitely recommend checking those out. Another one is from the American Psychological Association. definitely check their page out as well if you're interested in designing for natural disaster victims. So some of the things that people are thinking when they're having to evacuate by boat, okay, is how do we get out of here, right? Where's the boat? How do I get a boat? Where, I mean, they might be panicking, they might be shutting down, but some semblance in here is probably thinking, how do I get out of here? When we were trying to get out, there was some conflicting information. Some of the numbers that somebody in our neighborhood had, it wouldn't work. Another neighbor would have a different number. It wouldn't work. Somehow one person managed to get hold of people with boats, and they just actually started going door to door in the boats. The rescuers did. So another thing is, once you're out of the boat, let's say you get rescued and you get dropped off, which we were dropped off in a shopping center. Now what do? We don't have a vehicle. Where's the rest of my family? So for example, my extended family, who lives a few streets over, they were rescued in a different boat. And it took us a while to figure out where they were and for them to figure out where we were. Also, if you didn't carry your pets with you, what happens to my pets? Where are my pets? Sometimes what you'll have is people, they don't necessarily know who to call, so they'll call a friend. They'll call someone that's in a completely different part of the country. And that person, who's thinking in their right mind, will actually call the local authorities or local rescue groups and manage to get a hold of somebody. So people are reaching out on social media for this. They may be trying to find phone numbers, any sort of communication they're going to end up using, trying to save their friends and loved ones. So let's say you're at the shelter or you're at a friend's house, you evacuated. Okay, they're safe. Now what? Is my home okay? People are going to be worried about their home. There's going to be a lot of anxiety. There might be some anger. But I mean, certainly nobody's going to be happy. There might be some people that are relieved once they've processed the situation, but relief is probably going to come secondary to that anxiety. Okay. Another thing people are worried about is, are their homes secure? There's going to be reports of looters. Again, lots of information. You don't know if it's going to be correct information. You don't know if it's not correct. You just don't know what's going on in your neighborhood. When can people get back to their houses? How do I get back to my house? I don't have a vehicle, right? Rental vehicles were definitely in short supply during that time period. So a lot of people, it took them an extensive amount of time. They've had to rely on people for rides. In my area, we don't have a lot of public transportation options. Some people I know lost their jobs. So, well, what about my job? Will I have a job? When can I get back to work? People that had insurance, well, how do they get help? How do they get a hold of their insurance company? What's the next steps? We did not have insurance because we were told that we didn't need it. We weren't in a floodplain. That's what I was told when we bought the house, or when I bought the house. And so what do I need to do to rebuild? How can I make that progress? What resources are there? And then there's always the question, do people need to keep track of information like receipts for taxes? What records do you need? What happens if your records were under 3 feet of water? Another thing, how do you rebuild? How do you find contractors? So you have all these different worries. You have all these points of communication that people don't know the information. They don't know where to find the information because, again, these are not normally things that people think of in their everyday life. It's not like every day you're going to be working on your house or losing your vehicle. Another thing people are concerned about are health conditions. So like I was heavily pregnant. Is my baby going to be okay? Not just am I going to be okay, is my baby going to be okay? And he looked up at us from the ultrasound and was like, yeah, whatever, chill, it's fine, I'm good in here, relax. So obviously he was fine. So we were very fortunate in that regard, and he's quite healthy and happy and everything. So some of the feelings about communications and resources, people are going to be very frustrated because, again, they're not in a usual situation. They don't know what's going on. And when they're getting conflicting information, that frustration level and that confusion level is going to go sky high. There will be chaos in any disaster as far as communications go, getting information out to people who need it. There's going to be chaos, and no one's going to know anything concrete. It's not information that people normally try and get out to the general public. It's not something the general public is going to read and go, oh, gee, I need to, bookmark this for later. So and you're getting this out on a massive scale as well. So a lot of people were going to call FEMA. The wait time was extensive. Why am I mentioning that? Humans have a tendency of when they're scared, when they're confused, they want to reach out to another human. It's easier to talk to a human than it is to a machine, even though the machine is going to be more efficient to deliver that information. Humans still want that point of contact. They want that support, that interpersonal support. It's very important. When you're talking about getting all that information out, your volunteers, when they're trained, that's great. They're trying to do the best they can. They may have the correct information, they may not. When we were trying to get information, we would ask 10 different people and get 10 completely different answers. And that was on simple things like, you need to use this form, you need to talk to these people, you need to show up at this shelter, and they have a workshop on paperwork. Another thing is that your neighbors and friends are going to talk amongst each other. They're going to end up with different stories. They're going to end up with different financial support. Let's say we're talking about people with no insurance. The levels of support that people received are very, very different. And insurance, even with insurance, trying to find contractors, our neighborhood's still trying to rebuild. Our house is not done. Our neighbors' houses are not done. Some of them are, but even this is 2019. It's a year and a half later. It's still ongoing. Another point of confusion was pest control. When is that going to happen? Because they sprayed for air. Can I be outside? Do I need to bring my pets in? Is this stuff safe? So there was a lot of concerns and probably some misinformation floating out there. Finding volunteers, trying to find volunteers was really difficult. Trying to find the materials was really difficult. Again, communication about resources, any communication with trying to find equipment, food, vehicles. It was hard to find. People were getting very frustrated. They're also going to be tired. And they're trying to work in it's a race against time to try and get all of this moldy junk, just stuff out, because it's a public health hazard. It really is. Safety is one thing that people didn't necessarily think about because, again, they're in a hurry. They're not necessarily, if you had a seasoned contractor on site helping you, or you had volunteer groups who were already trained, yes, we're doing this in a safe manner, then yes, you had guidance. But some people, it's just, let's rip it out. So you want to take into account stuff like that when you're designing solutions to help with this stage of demolition and recovery. With rebuilding, people are starting to kind of get their sanity back, so to speak. They're starting to think a little bit more logically. They're able to navigate systems a little bit more efficiently, like finding apartments. But it's still kind of difficult to find apartments and hotels that had openings because everybody else is trying to do it at the same time. So this is more of a logistics issue. So there's frustration and there's fear that you might be in the shelter when it closes down. Some people were still in the shelters when they finally shut down and when FEMA shut down the hotel programs. People are concerned about how long they were going to be out of our house. Out of their house. We were probably out for about 8 months. And we moved back into a construction zone. And we were not alone. So you have those anxieties and those frustrations when people get back into their house as well. One of the biggest things about rebuilding and relocating is trying to find people that you can trust to do the rebuild. And again, that's trust is really more of an emotional aspect. That's something that people need. They need to be able to trust their contractor is going to do the right job. We had a couple of different contractors, one of which we're actually having to redo a lot of the work. If you've ever had mushrooms grow out of your shower, it's quite the experience. That was not what I was expecting. So we had to completely redo one area of the house because it was done improperly, and that was recent. And then when you're doing this, what recourses do you have? There's a lot of fear, there's anxiety on that one, and again, there's confusion, and a lot of times people don't have any recourse, so they have to find a good contractor to begin with. People that lost their jobs or they couldn't go to work because their business was damaged, the biggest question is, when can I get back to work? If some people lost everything they had and they had to relocate, and they ended up losing their jobs. Some places allowed their workers to work remotely, others did not, and those people were, of course, out of a job. Are there any career and financial resources? It depends by state, but navigating that system is often very complex as well. One resource, people, if you got a gap on your resume, people don't care if you were recovering from a hurricane or lost your job because of a hurricane. It's still a gap on your resume. And so career resources for people that were in this situation were few and far between. So there's everything that goes with being out of a job: fear, anxiety, a long list of emotions going on there, right? And then trying to work on the job and work on your house at the same time is also very anxiety provoking. Kids, I know that I know some of the kids in our neighborhood, every time it rained, had anxiety. So they had a little bit of PTSD. A lot of people in the Houston area did, because it rained so much and just would not stop, that anytime you heard, for the longest time, anytime people would hear rain, whether it was drizzle or a little bit on the roof, they would immediately just be on edge. So they start reminiscing those feelings, and all of that starts getting brought to the surface again. Finding out where, because some of the schools were damaged, where do you take your kid? This is another concern and worry. And then who can watch the kids while we work on the house? The kids can't be in that kind of a situation. There might be toxic substances, or there might be mold. You don't know what you're going to find when you start mucking out the house. And that's what we called it, is mucking, M-U-C-K. And that's the demolition. Also, what do you do health-wise? Do you take your kids' records with you? What if your doctor's office flooded? Did they have electronic records? Well, what if the systems are frozen? Did they have a disaster plan? Did they have backups? How do you get that information? Frustrations and thoughts, most of them are centered on getting the communication for the boat evacuations, trying to find out volunteers, communications, and then also any changes in the flood zones. People don't always know. So I know when I was notified, apparently, that a flood, that our house was in a different flood zone, didn't get it. I don't know how they sent it. If they sent it, we don't know. As far as I knew, when we were getting out of the boat in Harvey, I was still under the knowledge that we were not in a flood zone. Now, how we got 3 feet of water not in a flood zone was very, very interesting. So people are asking, how do you help? When you're talking about helping disasters, the biggest thing is jump in. So if you got a watercraft, call the local first responders, jump in there. If you got a vehicle, volunteer to transport people. Anything you can do, volunteer it. And that brings us back to our call for code. If you have a skill, please jump in and help with call for code. Even if it's, hey, I'm a disaster victim myself, I can offer my perspective, that's still going to be valuable experience for people that are designing those solutions. The next thing, I just wanted to say thank you, because I'm pretty much done. Thank you to everyone that participated in Call for Code last year. Hopefully y'all will be back again this year. And just thank you for everyone that helped us personally. And that's the talk. Are there any questions? Okay, great. Well, thank you very much. And up next is a talk, or up next is, what do we have going up next? Yes, and reactive for the inpatient, and then after that I think we've got a break, and then my teammate Helen is coming on and talking about Kubernetes. So all these, we have a lot of very talented ladies who are just, they're amazing. So we have a lot of great tech coming up. Come on back, and thank you very much for your time.
Hello, this is Mary Gragleski. I'm a IBM Java developer advocate by day, and I joined about 6 months or so ago. So promoting a lot of the Java side of things, and specifically with reactive Java in my past 3 months, 2 to 3 months. And by night, I'm actually a Chicago Java Users Group a meeting director. So it's keeping pretty busy and keeping our community really active with a lot, two meetups per month, and also have like other activities too. And also I participate a lot too in the Chicagoland tech community. I'm also with the Chicago tech experts community inside IBM. I'm with that and leading the external activities initiative. So that's something about me. I used to be a software engineer, like heads down, more like doing like delivery type of work. Have been doing Java since like 2000 or 1999, 2000. So it's been some time, but it's been so much to learn. I'm just like so excited. I feel like every day I go into work, there's something new, and that's what keeps me going. It keeps me young, and I think that's the way it should be for everybody. It's exciting. So thank you and welcome to my talk. So today I'm going to talk about reactive for the impatient. Really is the Java edition of reactive programming and reactive systems. And as such, this will be a very gentle introduction to reactive programming and reactive systems. And then I'll also be doing a survey of 4 popular reactive Java tools and libraries. As you can see in here, there's RxJava, which is React extension, come from that. And then there's Akka, and Akka is by Lightbend, and Lightbend and IBM have a very kind of strong partnership in that that IBM is also promoting the Akka platform. It's a very, very strong platform, very robust in doing reactive programming. And then we also have here is the Spring Reactor by Pivotal. So essentially it's a reactor project coming out of the Spring Framework project. And then there's also Vertex is Eclipse. So all these 4 tools and libraries, we call it less of like a framework in a very strict sense. So they are mostly like libraries that enable you to write reactive code. These are all open source, by the way, so you can kind of use them for free. And as such, too, IBM is a really a big advocate in open source technology, so we are really like for these. But for today, my talk too, I intend to do a more introductory and then compare the 4 and let you decide which one would be more appropriate for your needs. And I also want to apologize too. I just got well from a cold, so I may be a little bit hoarse in my voice. And if I speak too fast or not clear, please let us know in the chat, and I'll slow down. So thank you. Okay, so let's start. So why reactive, right? So reactive really is not something new at all. I mean, as such, our telecom industry too has already been using a lot of the like basically systems that I'm essentially using a lot of these principles and trading systems as well. Very responsive, high speed, like high frequency trading. They are all, in a sense, is really like reactive, a lot of event driven streaming. So why is it now, right? In the past 3 or 4 years or 5 years, it seems like reactive has become the word flying around in the marketplace. So this really is a result of some evolving changes and demands in the computing ecosystem. On the hardware level, as such, we have like CPUs are more powerful, multi-core, multi-CPUs, and hyper threading, like say Intel have those processor level. And also like now with virtualization, containers, that aspect of like, work that are being done on hardware being like enabled by virtualization, that's becoming a reality. So that the software systems used to be kind of cheap because you can run software, it's already a single thread, you can run on the hardware easily. But now with the hardware being so powerful, then the software systems needs to be essentially like structured in a different way to leverage like on the hardware advances that have happened in the past decade or so. So then like now comes all the reactive systems that are in place. Like for example, Lightbend comes up with the Akka system is quite powerful, which I'll go into detail. And then on the software application level too, as such too, I mean, we as consumers, we want more systems, enterprise level on all levels, consumer enterprise level. We want the systems to be fast and able to correct itself and being able to do a lot of sophisticated things. And then above all, we are all impatient human beings. We can't wait. So that's what like reactive comes in, because reactive implies like responsiveness, well, which I'll go into too. There are some principles regarding that. So all these are like driving the popularity of reactive systems in recent years. So what is reactive? So first, let me bring up reactive systems. They're basically follow this reactive manifesto. So here the URL will give you, will essentially is the site for the reactive manifesto. And the manifesto is headed or led by Lightband. They want to define a set of principles and guidelines, and it's meant to be like language agnostic. Is more like applicable to any kind of reactive systems written in any languages or frameworks. And the latest version is version 2.x, and the 2.0 came out in September of 2014. So the primary goals is that this should give like reactive manifesto basically is kind of guiding and say that its systems needs to be really flexible, needs to be highly responsive, and more tolerant of failures. And that's actually one very important aspect of reactive systems is how they handle failures and how it's more tolerant and how it is able to handle failures in a very like timely manner. So that's like something important. But you're welcome. Please go to this website, www.reactivemanifesto.org, and read more about it. There are a lot of information on there. So, okay. Now comes the reactive principles. Maybe some of you have paid attention and are already very familiar with these principles. So essentially, being responsive is like the big core requirement in reactive systems. By being responsive, it means that systems and requests going into a system needs to be processed and give a results back to the requester on time. So in other words, systems request needs to be handled in a very timely manner. And then if you go into here, oops, sorry, let me go back. Oh, how did it work like this? Apologize. Okay, so now I wanted to point out the resiliency. So resilient really implies responsiveness in case of failure too. And in any kind of situation when there's a failure, the system can have to do something to handle it also in a timely manner. And as such too, in the true reactive systems is that like failure is also like first-class citizens, because as such the reactive systems, let me bring that up, is that they are really like event-driven systems. So in an event-driven systems, any kind of data comes in and it's being treated like accordingly. It will be triggered, some action needs to be triggered. So when there are like failures coming into the systems, the failures themselves are also being treated as first-class citizens, meaning that those are also considered events. Unlike in a lot of programming language, for example, like Java, it used to be in a traditional way of doing things is that you handle your systems, you would say stuff like, if certain exception occur, then you do something. But in a reactive systems is that the failure will come in as just another event. But that event, in that case, then it will be treated like first-class citizen, so it warrants some kind of action that needs to handle that error situation. And by being resilient, meaning that the failure needs to be handled quicker and not be like left there, not doing anything. So now if we turn to elastic really implies scalability and high throughput of a system. So if there are many requests coming into the systems, then there should be resources automatically. The framework should then be able to handle the load accordingly. It will allocate more resources to handle those requests. And then if there are not many things going on, then the system also has to be smart enough to say, okay, some of the workers or processes, go to sleep or do something else, handle something else. So that's what is like meant by elasticity. Your system should be able to handle the load accordingly, and the resources be free up accordingly, or being like called up to do this work. And then last but not least, the message-driven aspect is a very important enabler to enable all three other principles to happen in a reactive systems. So message-driven really implies like isolating is asynchronous kind of processing. So then all of your components are being all isolated in time and space, and then they can be like handled like in a non-coupled fashion. So then that will enable the non-blocking, like asynchronous aspect of system. So then nothing will be sitting there waiting for something to happen. Like messages get sent, and then somebody will be there to handle. In the meantime, whoever sends the message can go and do something else. So that's essentially what it is. Of course, there are like more to this too. So I invite you to read more in the Reactive Manifesto. Now, some important distinctions. I'm just using this picture kind of deliberately because it's like fruit, right? You look in all these fruit, they are not the same. There's peaches and plums and pears. They're not the same, or nectarines. So same likewise. Reactive programming is not the same as functional reactive programming, and it's also not the same as reactive systems and architecture. Reactive programming is really like we're talking about event-driven programming. It nails down to into the mechanical aspect of programming, handling the events and emit these events like locally, handling the processing, and also like take care of the data changes and basically the handling the flow on that level. Whereas for functional reactive programming, being functional, it's okay. So let me go back a little. Reactive programming is it's basically in a reactive approaches is that the reactive the logic is always like driven by the change in the state of the data, versus in functional reactive programming is that you have a thread of control in your functional style of programming. It's really the thread, the thread keeps executing. And so whatever the thread of execution is, then it drives the program forward that way. Again, going back to reactive, that's really being driven by the data, changes in the data that would drive the flow forward. Now, in reactive systems and architecture, such as like Akka systems too, it's really like it's kind of taking the whole reactivity to another level. And basically in the reactive systems is think of it more like broader, that the systems is able to handle many components within an ecosystem. That's what essentially it is. So, and then for example, like a system like Akka, then it meets the requirement of the reactive principles of being responsive and being able to handle the load when there's like a heavy load, and it would then allocate more resources to handle those requests. And also Akka has a very good supervisor capability, in which it, one of the strong things about supervisor, the actor model, is that the actor themselves are kind of self-directing. It takes care of like data that is like any kind of changes, it triggers some action, then the actor model will react accordingly, basically. And if it needs more actor, it will actually kind of create more actor to handle some things, for example. And also in a failure situation, in a supervisor kind of situation, then it will basically allow like some components, if they are like under load, then there's some self-healing aspect of these components that actually will tell the supervisor and says, well, I'm really under heavy load, can you do something? So then it will be up to the actor, basically container of these components, would then say, okay, well, you're too busy, okay, I'll slow down maybe the flow, or somehow have some like flow control in place. So then like not one single component is overloaded. So it kind of like handles the flow aspect. So as you can see, reactive systems and architecture really handle like another level of complexity for like a whole system, the system as a whole. Okay, next slide. So here, I'll just point out this diagram too to describe a little bit about event-driven versus message-driven systems. Those are like two different things. So event-driven communication really takes like a soapbox approach. If you look at the top one, it's just like a publish and subscriber system. It publishes events, right, that happen, and then basically let others, the observer, that's what the terminology to use. So those are like people subscribing. I'm interested in what you're going to say. So in other words, the one that is emitting all these events, he doesn't care like who is going to receive it, because it's really up to the consumer side to kind of say, okay, I'm interested in what you're going to say. I'm interested in your events. So it's really like location agnostic. I don't care kind of thing. Whereas if you look into message-driven systems, message-driven, it really has an addressable recipient and a single purpose. So it's like envelopes, right? So the message needs to be sent out. So the framework, that's what like frameworks like Akka is good, because then you can configure it. And then if there's anything that needs to be communicated, basically on the coding application level, you probably don't need to worry so much how it gets there, because the framework will take care of it. Because as such, the message-driven system has the addressable recipient information. It provides that location transparency to the application level. So, okay. Now, I know that all those talking were kind of boring, so I decided to let me kind of wake you up in case you are like saying that, well, that's too much. So let's look at some real use case. I'm just bring this up intentionally because as I was thinking, preparing this talk, I was thinking, we got to have some kind of good use case for like a reactive. So I was actually in Tokyo for the Java users group. There's a big conference back in December. And so I went into some ramen shop, and then that gave me some idea that I think it would be a good use case to adopt like using a reactive approach. But first, we'll probably go from a reactive programming aspect first to see how we can implement, how can we make use of reactive programming aspect to handle like an ordering noodles ordering system. So I'm sure for those of you maybe like in the Pacific time zone, you're probably hungry. So anyway, let me kind of get into this first. So before I get into my use case a little more, I just want to bring up a couple of things to like terminology in reactive programming. So some patterns and terminologies. So reactivity is really reacting to like events that are coming in. So events are really the stimuli that stimulate something that needs to happen. And streams are really like primitive, like data that actually flows through a timeline. That basically they contain data that needs to be handled. Those are like streams. And observables in here, in reactive terminology, they are really how can I say, like they are think of like back to that other picture, right, that I had of land and observables. There are events that happen, then they are called essentially they are events that are on the timeline. They are really called observables in that case. And the design patterns that are being used in reactive programming, they're observer and composite and iterator. And these are very common Java design patterns, which I won't go into detail for now, but I want to kind of list out in here. Okay. Now, let me also take this a little bit deeper, or not too deep, but a little bit kind of explain things about the timeline and the events too. The very top line is just in a reactive programming scenario. The very top line, that's an event timeline. So the very top one, you see that there are no shapes. And what it is saying is that it's just a timeline with no events. In the second one, you see some circles and like pentagons and like triangles. Those are like events that happen. Some data is happening, flowing through the timeline. And then in that second line, you see that there's like a perpendicular one. That means that the stream has finished processing and terminated at that point. And the third one down, you see that there are shapes. So same thing, some events happen, all of a sudden you see like a cross. The cross really, what it is, again, it goes back to what I mentioned earlier, is that failure conditions are really first-class citizen. So another event happened, but this event is an error event that needs to be handled accordingly. And the very bottom one is is essentially an open-ended stream. So in a timeline, the stream will keep opening, and any events happen, you will see all the different shapes on it, but the stream itself doesn't terminate. So these are just some basic diagrams to illustrate like reactive timeline, the observables. So here, let me also give you a bit more concrete example. On the coding level, what they call these is rather than like methods, strictly speaking, they are called operator. So these are operators that are being used on the timeline to react the observables. And over here too, I decided to just show you this one. This is a map operator. So what it does is, okay, so also to let you know is that there are many operators, but map is one of them. So essentially in any kind of programming scenario where we have input data coming in, and we also want the data to be transformed. So the map is a very common operator, and what it does is essentially takes care of transformation of the data. So in here too is that you see that there's a timeline at the top here. There are 3 numbers, 1, 2, and 3. And then if you look into this data transformation operator map, so what the map does is that it takes the input and then it multiplies by 10. And so you can see it in here. So now if you look into the bottom there, left-hand side, it shows the code. So the observable basically will basically like have the input of like it's got the just operator, and then it takes in the stream 1, 2, and 3. Those are the 3 data events that it has. And then what it does is that it chains up, right, to basically transform this data and do a dot map and transform this data. So inside it multiplies by 10. And you can see immediately too, rather than this being a separate command after this, is basically it chains and then immediately does a dot subscribe. So the subscriber is like, think of it as like a client and server request and response all happening in one single command statement. So that's kind of one of the beauty of doing like reactive programming in Java too. And since Java 8, this is possible because of Java 8 has functional programming and streaming coming up that came out. So here I just want to illustrate is that it is a simple case, but it really shows the beauty of reactive programming. You can do the transformation right here. You have actually the input data, do a transformation, and you do a subscribe, which is the consumer subscribing to what the producer has to give out. So subscriber here is actually will then do a print timber.d, essentially print it out to system output, doing an item, and then shows you the transformed value. So on the right side, you see the output. It will print out item 10, 20, and 30. And if you want to look at more of these, this is like available. I took this out from the rxmarbles.com. It has very interactive site too. You can play around. There are many other operators like filter, flat map, and those. You can actually play around with it too. That site has some good information. Okay, so now it looks like I probably should move a little faster. So now I move on to reactive systems design. For this, I won't go into like a lot of details because it does get into a lot of the very deeper like reactive systems principles and patterns. But I just want to highlight there are like state management and persistence patterns, flow control. You can see message flow, fault tolerance and recovery patterns, and replication and resource management patterns. So these are like different patterns in a reactive systems design. And basically too, I would recommend too, there's a book by this author. Actually, I cannot get to my notes, so I can't remember exactly his name, but he's one of the Lightband engineers or architects, or maybe like their partners. He wrote a really, really good book on reactive systems design, and I have that URL towards the end of my slide. So if you're interested, you're welcome to take a look into that book and also the website too, towards the end. But now let me go to the next slide. I'll just bring these up. So in reactive systems design, I just want to bring out these terminologies. These days too, we have a lot of reactive microservices that are basically help in like application modernization, because a lot of existing systems are monoliths, right? They are like one giant thing and it's really hard to maintain. So we're trying to advocate to take a reactive microservices approach. You'll be amazed that the amount of code that will be reduced will be by a lot too. And then also the processing speed of these systems is actually very, very good too. I don't have the benchmark now, but maybe my next talk, I'll do some research on getting some benchmark to show you too. And again, reactive systems is essentially, it isolates the state, space, time, and failure. And a couple of those patterns that are kind of, I like to mention out here is there are circuit breakers. So circuit breakers are like what you maybe had it in physics, right? And they're essentially like, if there are any failures that happen, then there should be mechanism. So the mechanism is to basically stop the failure from like, going on. So that has that mechanism to handle any kind of failure situation. Those are like circuit breakers. Then there is also the back pressure, which I mentioned also earlier too, is essentially back pressure is that requests will in a flow, in a timeline, right? You can see there are many or many events that are happening, data is coming in. But let's say on the processing side, that component is just not able to handle. So then it builds up all the back pressure. So in a really good reactive system, such as like Akka, then you have like good mechanism to handle back pressure. So the components that are under load will notify the one, that's like the supervisor will say, well, I'm like really under pressure. I can't handle it now. Then basically the supervisor capability will then handle it accordingly and have more resources to handle these requests, or either that, or maybe like slow down somehow the flow control aspect. It will do that too. And then in reactive systems too, we're also talking about high availability and also like eventual consistency. So what it is that actually high availability and eventual consistency, they are mutually exclusive. As such, we want systems to be highly responsive, highly available, data to be ready, everything you requested, you wanted to come back faster. But then in reality is that we need to check the data first before we can make it available. However, if you check things, then it will then slow things down. Then systems won't be highly available. But the thing is, there's some theory that if there's this theory of eventual consistency is that, well, data itself will eventually be consistent. So sometimes we sacrifice maybe like a small, kind of percentage of data being inaccurate. And so basically, in order to meet the high availability. So those two are kind of like interesting kind of concepts, and also like how systems are being designed to handle these kind of opposing kind of needs in the system. So I encourage you to read up more on that. These are very interesting concepts to read about for reactive systems. Okay, so now what about microservices? So how are microservices related to reactive programming and also reactive systems? So in like microservices for reactive programming, they're essentially programming again on a programming on a single microservices. It handles some of the internal system flow and handles some of the data changes in there. But whereas like in microservices for reactive systems is that the reactive systems will provide the bridge to essentially connect all of the different microservices together in a larger ecosystem. So then that will achieve the responsiveness, the elasticity, and the resiliency of any systems. So that's what, in a nutshell, that's what it is. So now let's just slow down, spend more time observing. I just find this quote kind of interesting to say slow down and spend time observing, because the observables are being used in reactive systems. I find that in reactive systems, we are supposed to move faster. So I find this kind of interesting, this quote. Just want to put it there. And now let's get back to my design thinking part of the use case. So I was in Japan. So at the noodle shop, you go inside, as you look over in this picture on the bottom right one, you see that there are actually no regular tables. Everybody sit around kind of the bar area. So what you do is you go inside, the ordering system is self-service. However, there's only one vending machine. So you get a line of like 10 people. That night I got in, it was busy. So 10 or 12 people waiting, and you go in and punch in what you need. And not only that, they are only in Japanese, so it's kind of hard to understand. Then you put in your cash into it to order. And then basically once you place your order, you pay your money, then you get 2 tickets. And then at that point, you give the tickets over to the servers, and they take your ticket to kind of cook your noodles. But here's what leads me to thinking about like a design thinking of this system. So if you look over here, I have a bunch of people, those are customers coming in, they place the order. So once you place the order, they are like events. They are observables of the events, right? They build up the order. And the observers are really the servers in there. They are observing to say, okay, well, we have new orders coming in. However, in this particular case, they can't really cook the noodles yet because people need to sit down. So we also then will need another observables for the seating system. So if seats are open up, then it will generate like an event in there, and that says basically say, well, my table, there's a spot opening up, for example. And so in this case, then the observers, who are the servers, would then notice that, okay, once there's an open seat available, then I can assign a customer to sit there, and then I'll take his order and basically give the order to the cook to cook the ramen. And in that case, with that order that comes, and that becomes an observable when you go and notify the cook to cook the ramen or put together the ramen, the bowl of noodles. And then when the bowl of noodles are ready, then there should be a notification system that basically notify the customers that it is there, or more like notifying the server, so then the server can bring it to the eagerly waiting, hungry customers. So in that case too, the customers, once they place the order, they will become observers and observing to kind of wait for the noodles to come. So I just thought of this would be like a very good use case to basically use and reactive systems to see what happens. So, and I invite you too, if anybody is interested. I plan to be running an online code and coffee, and we're just gonna either design the system right away, or maybe step through and getting some basics of reactive programming to get it under our belt. So you are all welcome to join too. And please follow me on Twitter, and I'll let you know when my online code and coffee is open. So, okay, now I go into the next part of my presentation, which is about the survey of the four tools that I mentioned earlier. So first, I'll start with RxJava. So RxJava is really comes out of reactive extension, and reactive extension came out of Microsoft, and basically they came out. That was essentially reactive extension, or Rx.net. Then Netflix, in 2014, they were able to successfully ported it over to Java. And so version 1 came out in 2014, and at that time was a bit more like primitive, doesn't have the flowable and the flow control and some of the back pressure. So in 2016, version 2, they actually came out with the flowable and the back pressure. And this particular RxJava library, set of libraries, are very, very popular on Android because they are somewhat like quite easy to use too. It's more like you just basically include your library, and then you can use all the libraries from there, all your methods and libraries and packages from there. So as such, Rx and reactive, this reactive extension too is also available on some of the more popular languages, JavaScript, so RxJS, and of course .NET and Scala, Clojure, and Swift, and more too. So now I'll go to the next slide. I'll just show you quickly some sample code about why we should really consider switching to doing reactive programming. And look at, in a normal traditional way too, when you do hello world, it will take you a couple of lines, right? You have to like basically parse the argument, and then basically take the argument, parse it, and then say print and all that, and into like different statements, like more than just one statement. But look at how beautiful it is, right? In reactive programming, is that you can do everything in one command line. So essentially, in RxJava, you basically just have a flowable, and you do a dot from array. So basically, then it takes care of parsing the arguments in there, and then do the subscribe, again, the consumer part that consumes what has been coming in, can then like be all in one line. So over here too, it's very simple. It's just subscribe, then you do a system out print line hello, and then it takes an argument hello, reactive something. So, and here is another example of RxJava 2, but this is more like for just showing a little bit more too about a little more detail, but isn't really a program. It's just something to illustrate. There's the observable class. So the observable, how you can get your stream is doing a dot just, and then you can basically pass in your stream of data. And that's the producer. And then the consumer in here is basically what it does is just does in a primitive sense in this example is just doing a system out print line, prints it to the console. And then to attach the producer to the consumer, you just need to use the observable.subscribe call, and you pass in the consumer. So yeah, so this is like a quick kind of introduction to RxJava in a quick nutshell. Now I'll show you Spring Reactor. So Spring Reactor is actually based on Project Reactor from Pivotal. They are the ones that basically they came out with the whole Spring framework that's very, very popular in the Java world. And actually, the libraries too, the APIs are very similar to RxJava too, because the contributor to Reactor, he is also a project lead for RxJava, David Kanok. And this is built for Java 8 and higher, and so allowing for more cleaner interface, and it can also make use of all the Java 8 streaming and functional programming capability. So there's just a quote in here too from David. He says, use Reactor 3 if you are allowed to use Java 8 plus, but then use RxJava 2 if you are stuck on Java 6 or you need your functions to throw check exceptions. So that's just a note I'd like to point out in here. And then for Spring Reactor too, essentially there are a couple of libraries, and then to do your core programming, you use the Reactor core. Then there are also Reactor tests and the Reactor extra. Oh, actually, sorry, I noticed my spelling. And then there's also the Netty, and it has good integration with Netty, with adapter, and also Kafka streaming, and also like with RabbitMQ. And they're also incubating reactive streams for Foundation for .NET and JavaScript as well. Okay, now here's an example. This is Spring 5, the Spring Web Reactive. This is really a non-blocking web stack. So in a traditional approach, if you look at the top section of code, I'm using Spring MVC. So you see that there's a get mapping. Your call comes in, your URL comes in and /traditional. So what it does is it will do a get all products. And this is the traditional way. So you see that the print line, it says traditional way started, it will be shown right away. Then the next line, okay, then this is the one that actually goes out, basically call to actually make the call to get products. And guess what? In this case is that in a traditional way, the call themselves are synchronous. They are blocking, meaning that in this case, I go out and kind of gather the results, the outcome, make a query, whatever it's doing to the database, all these other services call to go and fetch all the products. In the meantime, it's holding up the whole thing. It's blocking. So then your method is not exiting yet because it's waiting for the list of products to come back. So when the products comes back as a list of product, then you see the next system out print line that says traditional way completed. And at that point, when this method get all products return, it will return that list of products. And then basically too, this will imply some wait time for this method to exit. However, if you look down here below, the reactive approach is using Spring Web Reactive Web Flux. You basically, over here, you have your get mapping as reactive, and you do need to tell it in text event stream value. And what it does is the get all will return a flux, a Spring Flux. So what a flux is that it's essentially, think of it like you going to the deli shop and buying some lunch and meat, and then you basically have to wait, and then you get a ticket. So, and then you wait, but in the meantime, you can go do something else. So that's kind of similar in idea in here. So you see that system out print line will do a reactive way using flux started that will show. And then when it gets to the next line that actually do the get product stream, the actual service call, it will actually return you a flux. It will just essentially return you that. In some ways, it's like a a ticket to you and says, okay, this the flux is flux products here, and then basically the third line here, system out print line reactive way using flux completed will actually show at this point. But at that time, your set of products have not been returned yet, because what is happening is that this is an async call, is non-blocking. So the call will get kind of get invoked. And then it does its work. Then basically this particular method would say, okay, well, I get back a flux handle ticket. then I will just exit. So this method will actually return before you get the set of products back. And of course, too, in a real life scenario, then you have your particular like built-in like capability to handle, okay, when the products come back, then I'll handle it or take care of it accordingly. But that's the idea of like how nice it is to do async programming, because you really free up everybody's time. You don't have to wait in between while things are being processed. So now let me do a really quick comparison then between RxJava and Spring Reactor. These two are really 4th generation libraries. They're also released around like 2017 timeframe. The environment for RxJava is the reactive extension environment. Spring Reactor is based on, it's basically Spring 5. Wait, hold on a second. Sorry, my screensaver came on for some reason. Wait, sorry. Okay, let me see. Okay, sorry. Okay, I'll go back here. Okay, so these are single-threaded, like non-blocking by default. I'll continue. Oh, and then RxJava is based on Java 6. It starts with Java 6, but it also supports Java 8 now. But Spring Reactor really starts from Java 8. And these are single-threaded, non-blocking, and they're event-driven, asynchronous, all these good stuff about async. And supportive of reactive streams. Now, reactive streams come from Spring too, the set of libraries. So RxJava support that partially, whereas Spring Reactor supports it fully. And the type of data producers, RxJava 1 has the observable, is more basic, and RxJava 2 actually has more support of flowables and single and maybe and the back pressure stuff too. And the controllers in the Spring Reactor is really the flux, which I talked about earlier. They basically represent asynchronous sequences of the values. And then there's also mono, and those are they're both basically mono and flux support back pressure as well. And the number of operators too in RxJava is actually well over 100. And Spring Reactor has a set of core operators. Okay, now after this, let me talk with Akka. I'll be speeding up a little bit as I notice it's already 3. So Akka, I mentioned along the way too, these are, this is from Lightbend. It's based, and IBM has a partnership with Lightbend. An actor model is not something new. It's came out of Erlang in the 1980s. Essentially, actor is based on the mathematical model, modeling for concurrency, handling concurrency. So, and also too, a lot of the messages comes in like it doesn't get buffered too, and that's an area is pretty interesting. If you don't buffer, you allow it much faster, but also too, then like it goes through like buffering. If you don't keep it, then it'll be lost. So there's some interesting discussion in there too. And they are event-driven. Location, it supports like location transparency, and it's very lightweight too. I won't go into more detail since I already mentioned about supervisor capability. That helps really a lot in the resiliency and recoverability of the systems. Now, I'll go into also like a Hello World example of Akka. So over here, you notice that Akka actually will involve a bit more coding because of the framework requirement. So here, like you see that Akka name, then basically it will do a new string and doing a Hello World class .get name. Let's go to the next one. Let's take a look in Hello World. So you see over here, Hello World extends abstract actor. And basically you look into the create receive there, the receive builder. So there's a bit more coding in here too. And basically, if you look underneath to the pre-start call to it basically is the pre-start there in which it takes in the argument as properties, and it create that property greeter. And basically, then the greeter essentially will have to like do a tell, and then that's when it basically prints itself what it is in here. Okay, oops. And now let's take a look at the greeter. So this is the greeter. It extends the abstract actor class. And you see their enum, their greet and done, the two enumerated value. So over here too, the receive builder, basically when it receives the message, then it basically will build up the, actually it builds up the message. So it basically, if it's equal to greet, then it basically will then print out hello world, and then also then basically do a sender.tell, and essentially then prints out what the name was that get passed in. So as you can see, Akka maybe involve a bit more coding in some case, but it's actually overall is not so bad too. But in comparison with like RxJava, it's maybe a little bit more, it requires a bit more framework kind of level of construct in there. Here. Oh, okay. Sure. Okay, yeah, no problem. Thank you. Yeah, I can't see my other screen. This takes over, so sorry. Okay, so this one, just a quick thing is, again, Akka started off by in Scala, because Lightband is started by Martin Odersky, who's the inventor of Scala. So it's just a quick example of it in Scala. Now let me just quickly going over VertX. So VertX comes from Eclipse, a very polyglot framework. You can actually mix and match RxJava libraries in it, Spring Reactor. Akka, I have to still try to find out. And the model it uses is called verticals. So essentially, too, they are being deployed and executed by the VertX engine. And it is event-driven, and the nice thing is it runs only when they receive a message. And essentially, the VertX event bus is the main thing that kind of like takes care of the flow of things. And it's not really restrictively tied to any container, so it can be used with other libraries, which makes it a very flexible framework or set of libraries. So quickly, I'll just show you too. The hello world in VertX is what it is. Again, it's also like a one-liner over here. Your VertX, basically you can create your HTTP server and basically binds it to port 8080 in here. And basically the request handler is all in one command line that takes in the request, and basically from the request, then you extract the argument and then prints it out. So, okay, so this is it. And now it gets to my almost last slide, but this is just a recap and takeaways. So reactive is really an overloaded word, right? It's really not for the faint of heart, but it's really for the determined. Once you learn it, you'll be glad that you learn it, because it really is bringing programming to another level of sophistication. And I'll just quickly go everything else I'll talk about. But I just wanted to point out too, however, reactivity is not truly, there are no true reactive systems, because right now with database, there's no like non-blocking IO on the database engine level. You might have heard, okay, there's some like database like support an async library, but those are really connectivity library. For example, Spring comes out with the R2DBC. Some of the libraries, they support like H2QL, and also I think the MongoDB too, MySQL. Those are really on connectivity level. But when you get to the database level, the engine themselves, they are still using blocking IO. So that's something I want to point out. And with this, it comes to the end of this. And sorry, I had to rush because I was talking too slow earlier. But just want to give you a couple of points of contact, how you can contact me, to follow me on Twitter. IBM Cloud, if you're not already having a cloud account, free tier, please sign up. And then the reactive systems is the highlighted one is where you can find reactive systems information from developer.ibm.com, and then the other links to the Lightband information. So thank you very much. If you have questions, please feel free to send me email or tweet me, or however way. Yeah, so thank you. Thank you very much.